Okay, next presentation is bridge aesthetics. Melissa Schultz is with the bridge office. She's the architectural designer, been with the office a little bit over 10 years. And I think it's all been working in the aesthetics area. So last time you talked with us, you were in balmy Florida. This time, I'm assuming not quite so warm, but
No.
getting warmer here. So anyway,
Yeah, no, turtlenecks today instead of beach wear.
okay. Well, thanks for joining, Melissa, and you can take it away.
Yeah, so I'm Melissa Schultz, like you said. I work in the MnDOT Bridge office. I am the only one that does this, so I do get kind of busy, but I'm basically going to be your contact for the next 20 years or so. I have no intentions of going anywhere. But I guess we'll jump right into it. Let's see. There we go. So here's kind of what we're going to talk about, kind of the why of aesthetics, because there's a lot of kind of controversy over aesthetics sometimes, and whether or not it's necessary. And then we'll kind of go into all of the different features that kind of make up aesthetics and that we use. And then talk a little bit about some of the other nuanced stuff like lighting, public art, and then go through a few project examples because that kind of tells you like the process that we go through as designers and stuff to create these types of features. So basically aesthetics is kind of dealing with the nature and the perception of being things that are beautiful. But bridge aesthetics, you really have to kind of marry that architecture and the engineering because above all, it has to be safe. First and foremost, anything that we construct has to be safe. So the aesthetics is always an afterthought to that safety. So why aesthetics? This is the really important thing. So context sensitive is one of the things that we do that it's kind of where we start in all cases. So a good example of context sensitive, I always say we don't build a hot pink bridge in a state park because it doesn't fit. We're not going to go up to Jay Cook and build something that's hot pink. We're going to build something that's, kind of got a dark stone look to it, something that really fits within that environment. Even some of our bright colored bridges, if you think of Hastings as that really bright orange, that orange is really part of that community. If you look, they have a lot of terracotta roofs. And so the bridge is a terracotta color. If you come from the north and you drive into Hastings, ever look out over the kind of roof lines of all the buildings as soon as you turn that corner and you start dropping down that hill. And you'll notice that the bridge really does kind of fit within that environment behind it. That's context sensitivity. That's really what we focus on the most. Wayfinding is also really important. We all use this. Most of us don't ever, well, maybe we do in transportation, but most of us don't do north, south, east, west. We will kind of give more visual cues. Like to get to my house, I always say there's the giant field with the big creepy tree, and you kind of use those things. We do the same things when we're driving. A lot of times we'll be like, oh, I recognize that house, or I recognize that building, or I've seen this intersection, whatever it may be. Aesthetics can do that too. Especially within MnDOT, we deal with corridor aesthetics. So like Highway 36 all looks the same. So if you're lost and you end up on Highway 36, you can look around and go, I've seen this, I know where I am. So aesthetics plays a role in that. I hear signature feature or gateway structure or things like that every day. Every community wants that sense of pride. We all are, we all tend to be attached to our home and we want to make it beautiful and we want to make it ours and we want to show our pride. So a lot of times aesthetics can do that. And we are seeing more and more communities push for visual identifiers of their town. Like pretty Minnesota famous one is like Pequot Lakes and their bobber or White Bear Lake and their bear. You see that and you instantly know. Another thing is the visually implied strength and safety. This is super important post the 35W bridge collapse. Bridges make people nervous and we don't have to have big columns, but we put big pier columns on our bridges because it looks more proportional. People kind of get nervous if you have this really heavy superstructure sitting on these little toothpicks. So we kind of beef things up to make it look proportional, even though it's designed to be safe with a smaller pier, but it just doesn't look that way to people that are nervous about our infrastructure. We do a lot of stuff with history and historic references, historic structures. There's also economic impacts, which we'll talk about that in a little bit more in depth later. And then a pleasing appearance is actually subjective. There are a lot of studies that show that we all do tend to prefer the same thing. So it's kind of subjective. You might like one color over another. But for the most part, we all tend to agree. So here's kind of a great example, my favorite, right? Like somebody's coming in for a job, who you're going to hire? Are you, you're not going to hire Jim Carrey because he's not really context sensitive, right? He doesn't fit in with an office environment. You're going to hire the person on the left. So the same type of principles, even though they're both in a suit, it really matters if it fits. There is also, kind of the socioeconomic types of issues here. You can see the neighborhood on the left would be, this is actually in a foreign country, but would be considered a slum. And then you can see they kind of mowed right in and built these new high rises. And they literally just went in and they plowed down the slums to do that. And we've learned that that's not a good approach. And aesthetics does matter in this case. You see those visual differences. That's how you know the difference. And our infrastructure can do that same thing. We don't go into an economically depressed area and build a bridge that looks economically depressed. We try to revitalize that area and bring it back to life and be forward thinking in that neighborhood. Same thing applies. I always think of this like, if your neighbor has, cars on blocks in their front yard and trash, it brings down your property value. Our infrastructure can raise and lower the property value of what's surrounding it. So we try and be very cognizant of these types of issues as well. These are really the 4 C's that we follow. So context, like I said, comprehensiveness. This one's super important. I actually had was like a city councilman legislator type situation at one point where they all wanted different things and they were so focused on spending the pot of money that the guy goes to me, he's like, can we take these steel circles and mount them on the webs of the bridge? And I was like, polka dots? You're suggesting polka dots? Because they were so focused on finding any way to spend that money, they weren't looking at the picture as a whole. And the bridge was already beautiful and already designed as this really cohesive piece. Cost, we all have a budget. That's always going to be an issue. And then constructability. I don't try to make things harder, and aesthetics it's not always easy to construct, but it does have that value we talked about. So here's how MnDOT lays out our cost participation. Level A, B, and C are the levels of our bridges. So A's are your St. Croix River crossings, your Hastings, maybe an international border, very big, prominent structures. B is almost everything that you're going to see. That's going to be bridges with pedestrians over, maybe a trail underneath, metro structures. Level C is going to be rural bridges. A lot of people think level C means they get no aesthetics. Most of them do get none. But sometimes it's just that they don't have a lot of viewers. But there might be some, like we've had some bridges where they're pretty small, but there's a lot of tubers that go under this, a bridge in the summer. So we might kind of upgrade the aesthetics on the underside a little bit. So level C can get some aesthetics, but it's just capped at 5% of the total cost of the bridge, not to exceed $200,000. Most of what we do is going to be that 7% of the total cost of the bridge, not to exceed $300,000. That being said, I would say most bridges, your average like metro bridge, doesn't get more than $200,000 for aesthetics. So that's not a lot of money. And aesthetics are everything above base. So that is smooth, pure smooth concrete. And then it's anything above that. So chain link fence is technically the base, even though you'll never see that on a MnDOT bridge, or you typically won't see that on a MnDOT bridge. That delta, so if we upgrade that to ornamental metal railing, that is your aesthetic allowance. And the difference between the two is how you calculate that 7%. Here's natural stone. We do this occasionally. We don't do it often just because it is pretty expensive. This was a perfect example of context sensitive. This is right near a granite quarry, so it made sense. The granite was inexpensive. Of course, I believe they probably lowered the cost for us because this is the great advertising for that quarry. So we don't do it often, but we do have some natural stone on our structures. Rustication, that's where we just kind of take these lines and we break up these pilasters, we break up large walls, we do little insets. They're all just detailed in the plans, and they just happen through form work. They usually don't have technically they have an extra cost, but we don't itemize it because it's just kind of part of those forms. Here's another example of that rustication, just kind of putting these little insets in to break up and give some definition to those pilasters. Texture skins, these are really giant mats that they use. You can kind of see actually the square that's built right in. So that was the texture. You can just give definition, play with shadows. It's a really inexpensive thing. They're not very thick. So they just attach to the form and provide a little bit of texture. Texture, now not something this minimal, but texture can actually be a safety issue. We see a lot of graffiti, and graffiti, people don't like to put graffiti on heavily textured things. Of course, sometimes they do, and we will see it occasionally, but generally they're going to pick a really smooth surface. If this was to be a really rough, random stone, it makes the graffiti hard to read, and it also uses a lot of paint. So people try to not do that. So sometimes you'll see areas, if you ever spot somewhere where you're like, why did they put money into a really heavy texture in this weird location? Sometimes it can be used for graffiti deterrent. It wasn't until I started with MnDOT that I learned graffiti actually is a public safety hazard. I mean, yes, you have your teenage graffiti, but in the metro, we might actually see graffiti that it's its own language. It might say, get your drugs here, get your guns here, whatever that may be. It's a language we don't understand, but they do. So we want to cover that up and deter that as much as possible. Kind of rib textures, we saw these a lot in the 70s. They're kind of falling out of fashion, so we don't do them a lot. Coursed stone, we quarry limestone in the state of Minnesota. The Mankato area is known for those quarries. So we do a lot of stuff with limestone textures. Here's a coursed one. Here's an ashlar stone. Fieldstone, this is what we see in more northern Minnesota because that's kind of the building material that's common up there. You'll notice this in a lot of other buildings. We usually try and take those ideas from the local areas. This is my favorite bridge as far as context sensitive is concerned. You can really see how this was done well. This barrier here is a form liner. You could see up in the bridge here, there's even a joint, and they blended this texture so beautifully. And then your riprap matches perfectly. So they painted this very well, but you can see it really just fits in. This bridge blends into the environment. This is up on the North Shore. So that it really makes sense. That's a scenic byway. We want it to keep that scenery. Our bridges really shouldn't stand out because the focus is what you're driving through. Here's a brick texture. This is a really cool product that we use. It is actually a real brick. So when you see brick on a MnDOT roadway, it is real, but it's done in a different way. So this brick is actually fairly cost effective. A lot of people automatically assume that features like this are very expensive, and they don't have to be, or they aren't necessarily super expensive. In this case, these little pieces are just stapled right to your form, and then the brick just sticks right in there. Then what happens is they pour the concrete and they pull the form away So they pull all these little pieces away and you're left with the face of the brick, and the concrete is actually making your mortar joint. So the concrete is filling in all these little holes and in between and making your mortar joints. So it's not done in the way of traditional stone. The longevity of this is actually really nice. On this bridge, we're even now seeing that they water these pots. We all know water is not friendly. It's a force. And the concrete is actually deteriorating underneath these pots, but the brick is remaining. So that's kind of nice to see. But cost-wise, some of these features, the brick is a little bit more expensive. You're looking at $23 a square foot. Well, you have the form liner down here, and that would only be $15 a square foot. But by the time you paint it and then added anti-graffiti coating on top of it, your cost is now risen to be equivalent to the brick. So not all of these features are as expensive as you would think. Custom forms, sometimes we do these, not too often because they do tend to be more expensive. They also take a lot of design time, and just being, the only bridge architect that we have, we just don't have the time to provide some of these services. But if a city or county or anybody wants to add additional resources or something, we are more than happy to accommodate these kind of fun things. So we use different form liner materials. All of this is called out in our specifications. So there's different types of foams that we kind of watch for because they might have environmental impacts. Some of these foams, like the one on the bottom that's a plastic, we don't really allow the use of. We're exploring some new plastics like HDPE. And then for the most part, we use elastomeric urethane for a couple of reasons. These products are a little bit more environmentally friendly from the standpoint that they can be used up to 40 to 60 times. Where, your foam beads, you have to be concerned if they're floating away. Are they getting picked up by the wind? And then they're also a single use. So most of our specs will call out this urethane product that you see on the bottom. So all of these textures, we designed to have them below grade because everything shifts. We know everything shifts. We also kind of have the bug holes in our concrete. We want to make sure that those get filled, that everything gets blended, so that we can have that look of like that Highway 61 bridge where you really just can't tell that you're dealing with concrete. So all of our specs kind of call out these types of things, parameters, I guess, so that it can look like real stone. We also do kind of architectural surface finish and special surface finish, and people get really confused on these things. So the way that I always think of it is architectural surface finish goes on architecture. Special surface finish goes on everything else. So architecture being those textures. So architectural finish, surface finish, and special surface finish have different textures to them. Architectural is very much like a paint, like the paint you would use in your house. It's very thin. Your special surface finish is very thick and it has a texture to it. If we were to put something textured onto a real stone, you would hide those imperfections of that stone. You really want to keep that. Imperfections make stone look like natural stone. So we use an architectural surface finish instead. We call out kind of a single colored and a multicolored approach. Here's an example of a single color. It's where we have giant walls. We probably can't afford to do, if you're familiar with this area, there is miles of walls and some of them are incredibly tall. We couldn't afford to do a multicolor on there, but you also don't want these giant, just plain walls because it would feel very prison-like, just not comfortable, very utilitarian. Where if we add some texture, we add some reveals, we add some pilasters, we can kind of bring down that height, make it more comfortable, make it fit in with the surrounding area, and just add some visual interest. So we can just do it and paint it one color, and you can see it still looks very nice because you get a lot of shadows. The rougher the stone, the better a single color is gonna appear. Here's an example of a two color. So they color it, and then they go over it with a highlight color to kind of really accentuate those divots and those pock marks and all that stuff. Then this actually does have 3 colors on it, which would be the grout lines as well, but we don't count that as one of the colors because it's not one of the colors used to kind of in that blending technique. Here's an example of 5 color. You can see that it looks a lot more like natural stone. You know, these stones are different. You know, this one has, you can see the rust spots in it. This one's got some reds in it, some browns, some yellows. Here's a good example of what we don't want to see. And this is kind of a, you know, we need to have good partnerships. So this is actually a culvert. The city used real stone on their side. We did not on our side. And we were going to do form liner, which is our common practice. And so they painted each stone individual. So you have one pink stone, one gray stone, one white stone, where they didn't blend them. They took the spec saying, you know, 5 colors, and they painted them 5 colors. So these are the kind of things that we want to try to avoid, because this is what's on the other side of that. And, you know, as designers and project engineers and things like that, we want to make sure that we are keeping up with what our communities are doing and really listening to the stakeholders and the constituents and working with what they're doing and not going against it. If we were going to match this, we should have had something closer to what's on the right. Really taking the time to make sure that that was done right. So we do use anti-graffiti coating on stuff. Maintenance really doesn't use it. We are always chasing winter, so we have that huge problem. Most of our graffiti happens in the metro area. The people who handle graffiti also handle traffic control. So they're going out, they are, you know, setting up traffic control and then quick running to a spot, painting over the graffiti, and then going back to that traffic control. So really it's tough. Anti-graffiti coatings are sacrificial coatings. So usually most of them are. So when they need to go out there and they need to pressure wash it, they need to let it all dry, they need to go back, they need to put anti-graffiti coating back over it. So you're looking at more steps than we typically have the manpower or the forces to do. Also, pressure washing and things like that in a Minnesota winter, there's no way you could clean up graffiti on some of these cold weeks, but you can go over there and paint it. So they tend to not use this, but like I said, we tend to also not get as much graffiti on our multicolored surfaces, but we will still use it. So anything that has a multicolored surface, we put anti-graffiti coating on because we hope that we can wash it off. But then also it does still provide a nice layer over the top. When they're doing those blending techniques and stuff, they might not be getting a good product thickness. So if we put anti-graffiti coating over the top of it, we're kind of adding some thickness and some protection to that color. So it's not a total loss if we don't use it for its anti-graffiti coating purpose. You will also see that we have test panels for all of this. So they have to do the texture, the color, and anti-graffiti coating all on a test panel to make sure that we can do that. Test panels are really important because they are basically a contractual, they're a contractual document to an extent. So our special surface finish, this is where a lot of people say, hey, you know, do we have to color our bridges? Why would we do that? Can we just leave them plain concrete? And the guy who sat next to me for many years, he was always like, nope, they should just be utilitarian. It's a waste of money. It's a waste of taxpayer dollars to be painting these things and then have those paints fail, you know, over a 50-year lifespan and need a repaint. So, but now our coatings are such that they actually have chloride protection in them and they serve other purposes. So they do save us money. They reduce concrete finishing. We don't have as many requirements for some of that finishing because those special surface finishes have those textures. They give a uniform surface. They allow for that color, so that kind of follows in more what the public would like to see. But now they can be used as a curing compound. We are always chasing winter, so they can actually just now go over with these new special surface finishes as a curing compound, just cover it right up. and not have to kind of wait that 28 days we used to have to wait with paint. But the biggest thing is the chloride protection. So the new ones provide a lot of chloride protection, which is going to extend the life of our structure. So no matter what, we are going to paint a structure. What color we make it doesn't really matter. That's just a bonus. If you work with MnDOT specs at all, you're going to see something in here now that was never in here. And that is, a lot of our specs will now call out the aesthetic level of the bridge. The reason this is important is because that's how we're going to test products now. So we have, like, let's say they want to do a new special surface finish. We're not going to let them put it on a St. Croix River crossing because A, that's a huge structure. So if it fails, our fix is going to be very expensive and very problematic. And then also public perception is going to be terrible. So we would have them start using those products on a level C structure, and then they could move up into a level B if, you know, after a review period of several years, and then they could move up to the level A types of structures. So that's where you're going to see those aesthetic levels also come into other places other than just the cost participation side of it. And a lot of our stuff, special surface finish is pretty much the only thing that aesthetics has in the approved products list. Kind of forgot what forgot what it was for a second there. The approved products list. And you'll see here that that aesthetic level is all, you know, we've been using this product for a long time, but when we want to start using new products, you'll start seeing, you know, that one can only be used on level C, and then it would be bumped up to level B. So we're hoping to get more products. And I think you're going to start seeing a few more kind of aesthetic elements in the approved products list, just so we're very cognizant of not single sourcing certain things. All of our surface finishes now, you know, they use a quality control plan, which I won't go into much with you guys, but basically it's really, a lot of people question too, if you'll hear that we now have kind of a monetary penalty for our aesthetics, not for the color of a structure. And a lot of people are questioning why. Like, does MnDOT really care that much if a structure is a shade darker or a shade lighter? But what we're actually looking for is problems in the product. So what we're measuring is we're going out there now and we're looking at the colors and we're looking at the delta E's. So they'll hold up a gun and they'll measure it and it'll give us the delta E, which is kind of how different that is from the color it's supposed to be. And that they can tell us that with this instrument. And that can tell us if there's any problems with the product. So we aren't concerned because in some of these cases, our eyes could not even tell this delta E difference. But that is the easiest thing that we can measure to figure out if there's something wrong with the product, if it, you know, was cut with water, if it wasn't properly mixed, whatever it might be. So we are now kind of trying to it'll give us better product in the long run. MnDOT is moving towards a standard color palette. We've been moving in this direction for a very long time. It's not truly finalized, but this is what it's going to be when we're all done. When I started, we found like 60, 80 dark browns that I was finding. I mean, there was tons of them. So we started being like, let's just stick with 3 colors. Pearl gray has pretty much always been used. That's the first color when we first started painting bridges was pearl gray. We have a lot of bridges that use this color. The light buff is kind of our more modern color. And then MnDOT gray was a proprietary color that was done back in the day. So these are really our main 3 colors. If you move into outstate Minnesota, like District 6, Southern Minnesota, for some reason, they don't have the light buff, but they almost exclusively use this light tan. And then you have iron ore, which obviously is up on the Iron Range. They do have a lot of this color in Duluth, Virginia, Evelyn, all through there. Because again, context sensitive, right? And then you're also going to see we have colors that we use on our metal, and we've kind of isolated those as well to just a browns, grays, and greens. So we're slowly over time getting these refined in. if you've worked with colors at all, you're going to kind of notice that there's a federal color, an AMS color, and an RAL color. That confuses a lot of people. It doesn't actually change the color. It's really the name. So what happened was the federal government owned a palette of colors, and they say, hey, all state agencies and like the military should all use these colors in this book. And they decided they weren't going to do that anymore, and they switched it to AMS colors. So federal colors and AMS colors are exactly the same thing. It's just the only difference is that the federal government is not managing it anymore. A private company is. So it's really all that means. And then RAL colors are the European standards, which for some reason the powder coating industry has chosen to use those colors. So that's why we have both, and that's as simplified as we can get, because we have to deal with what the industry is using for their color palette. So ornamental metal railings, these are probably the biggest feature on a bridge as far as aesthetic goes. They're the biggest thing that we see next to color, and we can play with them a little bit more. On railroad bridges, they have to be 10 feet tall, so they can be pretty prominent features of the bridge. Architectural concrete paving, this is an interesting one. So a lot of people don't know or understand that this can be a safety feature. We actually had a bridge down in Austin, Minnesota, where there was a senior center on one side and a grocery store on the other. It was also a very, very, not very wide sidewalk. I think it was only like 4 feet, 4 or 5 feet. It wasn't very wide. But as we age, we have a hard time seeing changes in height. And sometimes people would occasionally fall off the sidewalk into traffic. Well, if we put these types of features on our bridges where we have this stamped or roughened texture, it can be a visual cue for people. You don't want to ride your wheelchair there. You don't want to push your stroller there. It kind of can be a barrier to an extent to keep people away from that edge. So it can be a little bit of a safety feature. We mostly now at this point do tooled or stamped. We don't do a lot of masonry. This is Minnesota. We have freeze-thaw cycles. Our bridges move a lot. It's just not really a great thing to do that kind of masonry. I get a lot of pictures from like the South saying, oh, this is beautiful, can we do it? And living in a world where we plow and salt, usually the answer is no. We're also doing more stains and color hardeners and colored release agents instead of integral colored concretes. We've noticed that integral colored concrete just isn't holding up as well. Its lifespan is not as long. So financially and longevity wise, we're trying to avoid integral colored concretes. Outside of maybe our precast elements, which would mostly the only thing we do in precast are, custom emblems, like sometimes we'll have a city name or something like that, and then kind of these precast caps. That's about all that we're going to do in a precast type of a situation. Lighting. This one is always confusing. If you actually read kind of the cost participation policy, it's a little confusing. But what it comes down to is MnDOT will pay for lighting that is deemed necessary for safety, which almost entirely becomes your roadway lighting. So MnDOT will pay for roadway lighting and fixtures. Though that roadway lighting will almost always cast enough lumens onto a sidewalk to make it safe for pedestrian travel. However, pedestrians feel differently in some cases where it still seems a little too dark and people don't feel safe. Or there might be, communities that have already kind of a pathway of lights. They want to keep those lights going, that type of thing. So you will see your ornamental lighting, your pedestrian lighting that's like this. And then we also have that architectural lighting that you see like on 35. Hastings has rope lights. Some of our other, like Lowry, things like that, they have their own lighting systems, even though that's not a MnDOT system. those types of systems, architectural lighting and pedestrian lighting, are paid for by others. MnDOT will only pay for that safety lighting. Public art. So from an engineering and a design perspective, this is becoming a challenge. I encourage all of you to look at it as a fun challenge, even though it's tough sometimes. So a lot of communities and cities are developing public art policies. MnDOT now does have a public art on trunk highway policy. Basically, MnDOT cannot pay for public art. It is against state statute. So the Constitution says, of the state of Minnesota, says that transportation funds must serve a transportation purpose. Public art does not. A lot of people get kind of confused with what's public art and what's aesthetics. Aesthetics are really an upgrade of some type of feature we already have to have. And like I said, we already know there is a monetary value to that, and that there's, you know, it can affect economics and things in those specific areas. So there is a transportation purpose or a purpose as a whole. Public art is designed by an artist, and the community must design for, pay for, and maintain it. But we are seeing more and more communities kind of do that. Since those funds come out of other places, we have to be really, really careful of where those funds come from. We had a case where a woman in the neighborhood just raised money, and she got $32,000 and contributed that to hiring an artist and developing and upgrading the railing on a bridge. So we have to understand that this money comes from the public in a different way. I mean, obviously, you know, MnDOT, cities, everybody's using taxpayer dollars, so we have to be cognizant of that and careful of that as well. But this is a little different because these are more personal dollars, where a lot of times they're crowdfunded to an extent. But they do have to meet all safety criteria. You're going to see a lot of coordination. Here's an example of public art. This railing was designed by an artist, and then also the form liner that went in here was designed by an artist. We also have a railing with bronze emblems in it. We're just getting more and more requests. A lot of times public art has a hard time being funded, so we get more requests than we get actually built. But I do see a huge uptick in that. We do require that our as-built sheets are always filled out and turned in. There's a lot of value in as-built sheets that people don't really recognize, such as if we have a failure in something, we want to look at that as-built sheet. So a notorious one is Highway 610. We painted the beams green. They faded to like a peachy pink color, which is just odd from green to go to peach or pink. By using as-built sheets, we can figure out, is it always that color? Is it a certain contractor? Is it a certain paint manufacturer? What is causing those problems? And we can figure all that out through our as-built sheets. So we do highly recommend that the as-built sheets get turned in and that we can use them going forward. Or sometimes changes happen in construction, and we want to know that because it'll just get lost, and then we'll go in with a project 5 years later and we'll have no clue what they did on that other bridge, and we're trying to match it, and now we have to take more time. We might have to travel to that structure to figure it out. So definitely having these things filled out is a good thing. I'm going to kind of go through some project examples and tell you kind of why we did what we did and how this works. So this was Highway 100. This was the first highway in the state of Minnesota. So when we came through and we redid this, they really tried to keep some of those historic feelings, you know, a more historic light structure, the railings, the colors, the textures, all of that really fit into what was happening at the time. If you're familiar with this corridor, you'll know people used to travel here. They used to come to Highway 100 just to drive the highway because it was such a novelty. And there was these beehives that were kind of these beehive ovens that people would stop at as a wayside, and you would have lunch, and it was a huge deal. It was a destination. And this type of an ashlar stone texture is what is also used in those beehives. So it's taking those same things from history. This is a good example. If you look into Woodbury, this very much fits the community of Woodbury as far as their colors and textures. This is on almost all of their buildings. They also paid to have these planters, which they upgrade, they water, they fill. They do a really good job with that. Like I said, in Lino Lakes, this one's up in Lino Lakes, but you'll see, they kind of have a community identifying features on this structure. So you get here and you're like, oh, hey, this is Lino. We must be in Lino Lakes because, the light fixtures have a blue heron on them, and the reeds that are in the Lino Lakes logo are also built into that railing. So we're seeing a lot more of these types of, more of like an icon wanting to be placed on a structure. This is a lot of people don't even realize they're going over a bridge in this case. This is a 35W over 2nd Street. This is just north of the collapse. So this was replaced as part of the collapse. This is not a great area. There is a lot of crime down here. It's a great place to see a drug deal. It's very dark. It's very tunnel-like. You see a lot of graffiti here. But what Fig Construction did was they had school children come in and build these tiles. And what that did for our structure, so obviously that's not easy. That takes a lot of project coordination. You have to coordinate with schools. You have to generate interest. They had to, get the school children there, safely have them manufacture these tiles, store them, wait for them to, dry, all of those things. So it's not easy. But what that did is it stopped a lot of the damage to our bridge, because people don't want to damage what they now have ownership of, because, it's your neighbor, it's your sister, it's your cousin that did these tiles. So people in the community really took ownership of that. So these types of features, while inconvenient from a designing and an engineering perspective, have a lot of value in the real world. Margaret Street over 36. If 36 kind of goes through and you don't even realize you're in North St. Paul. North St. Paul is a little bit off to the south. You don't really see it. So we took the colors and the textures that are found in their downtown and we moved them out to the highway to really say, hey, we have this beautiful little downtown that has all of this beautiful brick. Come to our town. And then Granite City Crossing, you have obviously granite. Just kind of makes sense that you would do that in St. Cloud when you're dealing with those granite quarries right next door. This is probably my favorite structure, and it's in the middle of kind of nowhere to an extent. This is Highway 58 over the Zumbro River, and what this bridge was is we had to take it down because it had reached the end of its life. But the original bridge was dedicated to soldiers and had this particular design. So what we did was we tried to keep it as original as we could, and we just upgraded the safety features. So we had to add a barrier, but we tried to put a railing on it that was very similar. We tried to put these pilasters on there that were very similar in a similar configuration. And then we took the plaque off of the original one and rededicated this one to soldiers as well. There's even a tank sitting off into the corner of this picture. So some of those things have a lot of meaning to people or to the community, and that's really what we look for in aesthetics, because having that ownership, like I said on the 2nd Street example, really makes a big difference. And in this case, this bridge is probably photographed a lot in the background, simply because the covered bridge was right next to this, off to the left of this image. So you're going to see this in the background, and that can improve tourism for communities like this. So that is all I have. Does anybody have any questions?
All I see in the chat is just one comment, a great idea on the graffiti management, having local participation. Well done. So people
nice.
recognize the benefit of doing things like that.
Yeah, there's a lot more benefit. We learn more and more. There's more benefit than we ever would have thought to some of these things.
Anything else that anybody has want to type in? And seeing none, thanks, Melissa, for sharing your expertise and knowledge. Appreciate it. Let's take about a 4-minute break to 1:45, and then we're going to come back with retaining walls. One of the things as we were developing this class and talking to some of the resident engineers, they thought it'd be good to have a presentation on retaining walls. And so to give that presentation is Joe Black. He's the structural wall engineer for the MnDOT Bridge Office and been with the department for over 10 years. I'm not exactly sure. You can explain a little bit more, Joe, but Joe has a lot of experience on walls and different structural systems like that. So with that, take it away, Joe.
All right. Well, I'm going to share my video because I was asked to, and if anyone wants to tell me to turn it off, you're welcome to at any time. As Paul said, I have about 10 years with the department. He's got a good memory. It's actually 11 years, and the only reason I can keep track of it is I had a child born shortly before I started work at the state. So I've got an added advantage. And I do have a little bit of experience with wall construction. And before I swing into it, I just want to make sure, Paul, what time would you like me to try and shoot for finishing?
Let's see, you're scheduled for about a half hour, I think. So that would put us at, say, roughly a quarter after 2.
Okay.
2:15-ish. But it's better to get the information. So we have a little bit built in at the end of the day if needed.
Okay. Well, I'll do my best. The main purpose of my presentation is to just present the basics of retaining walls and some of the things that you should expect to see during construction and the submittals that you would expect to see also. As I put this together, I know there's a lot of information that I excluded that may be of interest to participants. Please feel free to ask specific questions, and I will do my best to answer them. So with that, the way I organized my presentation was sort of to look at our most common walls first, and then talk in generalities about some of the less common walls and what we would expect to see. I think what you'll find during construction is many of these walls, even the less common ones, have similar expectations, and it's sort of based on the components of the wall and who designs those components and what they're made up of. Are they a proprietary component or are they an engineered component by the engineer of record, so the person who designed the wall? So I'll go through our cast in place walls, which is still our more common wall type, and then I'll go through more in depth with our mechanically stabilized earth walls, which is quickly becoming more common even than our cast in place walls. We'll look at our precast modular block walls, and then soil nail walls, and then I'll go over briefly modular block walls and reinforced steepened slopes, just to give that broad scope. So starting with the cast in place retaining walls, these walls can be standard walls. We have standards with the state that we've developed for wall heights up to 30 feet in height, depending on the slope behind the wall. But you may also see a non-standard wall in a project. These walls there was something about the project that made this wall need to be different from what we would have in our standard wall plans. And then we don't see them very often, but you can have what's called a cast in place gravity wall, which is just a mass. But they all sort of function the same way. So as we go through this, the principles of the wall will be similar. And these walls are built much like our bridges, though the plans may be slightly different. The submittals for the project and the construction expectations are very similar to what we would see for a bridge structure. So for example, in the picture I have here, You see a checkerboard type construction where we cast every other panel, and this is common because our CIP walls have that same restriction that concrete panels can't be cast next to each other within a 72-hour period. And so to facilitate a faster construction, oftentimes contractors will cast every other panel in our CIP walls so that they can wait for 72 hours and then cast the other panels. We have this panel structure in most CIP walls because of the expansion and contraction expectations on the structure. That just makes sure that we have a better product in the end as the wall expands and contracts over its life. It's not going to experience undue amount of stress because of the way it's constructed. I just heard you had an excellent presentation on aesthetics, so I'm not going to go too much into the detail of aesthetics on these walls because they are very much similar to what we would do on a bridge. So how does a cast in place wall function? So a CIP wall, this is the most common wall you'll see on any project. This is a cast in place cantilever semi-gravity wall. Most walls of this nature, it's a cut wall, meaning that they cut the section first and then they build the wall and then they backfill behind it. So the wall mass is what resists the load from the soil. So here you have your wall mass. Its weight and its shape is built to make sure that as the soil wants to push forward behind the wall, that there's an equal amount of mass to resist the overturning, which is the wall wanting to tip, and also the sliding, the wall wanting to push forward, and the bearing of the wall. So the size of the footing is determined to make sure that the wall doesn't settle more than we would want. And so behind the wall, you have your retained soil. And I'm only going to go over this once because all walls sort of function the same. You have the retained soil behind the wall, and that's just the soil that's trying to push the wall out of place. For these types of walls, you have an added advantage, and that's that material over the what we call the heel of the footing. So you have this toe of the footing and the heel of the footing. It does try and push the wall down. It wants to it's pushing out on the wall, but it's also adding weight to the wall itself because it's over its footing. So it resists overturning. So it's sort of part of the wall, but isn't part of the wall. So we have that hashed area there. So that's basically how any CIP wall works. Gravity walls will be shaped slightly differently. They won't have a footing. They'll have just a mass of concrete, but that mass of concrete is meant to do the same thing that this wall does, and that the mass is large enough that it won't push forward and it's not going to rotate from the forces on the soil it's retaining, or from the forces from the soil it's retaining. So this construction, this just shows what that looks like. Again, basic forms. The walls are not all that different from what we would see in any cast in place construction. And as far as submittals, I mean, there may be detailed faults work or form plans that are required. That isn't common, but it can be required. So those might be something that the contractor would have to submit. Any other items are very much what you would see in a typical bridge project. So nothing overly exciting in CIP walls. So that is just my review of cast in place walls. Obviously not very detailed. Does anyone have any specific questions before I move on to the other wall types?
I don't see any that have come in on the chat.
again, if there is, we can obviously pause and answer those. With that, though, I will move on to MSE walls. I'll spend the majority of my time here because MSE walls, as I mentioned before, they're becoming quite common and pushing toward being the most common wall we build. And there are many reasons for that. One reason that these walls are becoming very popular is they're relatively inexpensive to build. So they save a lot of costs when you're building them. Now, one reason they're not that popular is sort of shown in this picture. People who are really into aesthetics, like Melissa, they just love these walls. Well, actually, Melissa really hates these walls. They are paneled. You've got joints every 10 feet in the vertical, between the vertical lines, and the horizontal lines are about 5 feet apart usually. And aesthetically, a lot of people don't like to see their that broken up in that way. Just too many joints for them. Maintenance has a lot of fear over these walls because there's so many joints. Plants could start growing in those joints and so forth. But despite those fears and despite all of that, these are still an inexpensive wall to build. It was a technology that was introduced in Minnesota in the 1970s, and we've been building them ever since. And they've become just by far one of the more common walls to be proposed on any project. Nationwide, they're beginning to represent more than half of the walls that are built. Not quite there in Minnesota, but will eventually follow that trend. And part of it is just simply the materials you're using. Concrete, you have a mixed design. There's a lot of components that go into it. For a MSE wall, the biggest component is the earth fill. And earth compared to concrete is cheaper. So they're less expensive in that sense. The components of a wall I'll walk through, but they're also, you don't need specialized labor to build them. So there's a lot of benefit there. But there are many things with these walls that make them more difficult to build. The biggest problem to designing them is simply that they're proprietary systems. So it's not really designed by whoever the engineer of record is on the project. It's designed by whoever supplies the wall system because it is proprietary. So we'll walk through each of these components. So the first component is the leveling pad. So these walls don't really have a footing like a traditional CIP wall. It's a leveling pad. It's an unreinforced concrete component. It's there to make sure that the panel face is sitting level and looks nice in its final position. So there is a lot of care that needs to be taken in placing that pad so that it's level and so that the panels sit nicely on it. But in the end, once it's buried, we actually don't really care what happens to that pad. And in many walls across the nation, they found that these pads will eventually just disintegrate to sand. That's fine. Once it's buried, once it's served its purpose, the leveling pad is a small part of what the wall really, how it will really perform. And then we need earth reinforcement in an MSE wall, and earth reinforcement will be of two types. We have what we call extensible reinforcement. That's more these polymer geogrid reinforcement, and then inextensible, which is usually our steel strips or steel mesh. I have some example of those, but you can see the steel strips here. Extensible and inextensible just describes what happens to the reinforcing by and large as it's being placed. So the steel strips, will not stretch as you're compacting the fill, but the geogrid does stretch, and so there's some extra steps there for it. Um, so those are a couple of different reinforcement types that we see. And then by and far, the most important piece of any MSE wall is the structural backfill. And so the structural backfill makes up 95% of the wall itself. And so it's really important that that material be very carefully inspected to make sure that it meets the specifications. All of our walls have the same requirement for backfill now, and that's that structural backfill found in our spec 3149.2.D2. That's the same type of fill you're going to see. These walls have an additional requirement to make sure the pH isn't so high that it'll damage the reinforcement, or too low that it'll damage the reinforcement. So the longevity of the wall has that is why that pH requirement is there. But this is by far the most important piece of this construction. And then you have these facing panels. Facing panels for most of our MSE walls are a thin panel, approximately 6 inches. I've seen as large as 8 inches. I've seen proposed as large as 18 inches, but most often the precast panels are really quite small, 6 inches thick. We use, although it's rare, precast modular block units. Those are the larger precast blocks, and we'll go into that a little later on. They can also be used as a facing. And the facing serves in a small but essential service in keeping the soil from raveling and exiting the wall. So it's there to make sure that the sand stays where it should be in the wall performance.
Joe, there's a question came in. What is the general depth of excavation for these types of retaining walls?
So generally, they're going to be taller walls. That's another reason they're used. So these types of walls would be used in situations where you're getting wall heights over 15 feet. I've seen 20 feet tall. You can get as high as 50 feet with them without too much problem.
I'm thinking the question is the depth of excavation. So you're starting a wall. How far down do you need to dig to start building up?
Okay, I see what you're saying. So the wall itself in our spec is embedded 3 feet down. The leveling pad is another foot below that, so it's a foot thick, but that can be trenched. So the bottom of the wall, and we do this with most of our wall systems, we like to see that at 4 feet below. But we feel that that leveling pad serves some protection for frost heave. So we make that a foot thick and then bury the wall itself only 3 feet deep for the most part. Does that, am I understanding you correctly, Paul, when you?
Yeah, it's a question in the chat box. So I think that sounds good.
Okay. So some minor components you'll see on these walls, there's usually an elastomeric pad between panels that each panel will sit upon so that you don't have concrete on concrete. Of course, you've got the connection for the reinforcing to the panel as another component. Those are of several different types. I'll walk through some now. This connection is the most common that we see, and it's just a bolted connection between steel strips and the wall panels. We also see this connection, though it's not as common, which just consists of some loops. This is more for a wire grid reinforcing, and you put the wire grid there, and then you just slide a bar to hold the grid in place. And then, of course, for our precast modular block walls, you might have a structural connection, much like is shown here, where a foot-wide strip of extensible reinforcement will go in there. The geogrid will then be pulled into 2 layers. And that's a structural connection, or it might just be a friction connection. So a friction connection is just simply you lay out the mats of the geotextile reinforcing, and then you sandwich it between 2 blocks. So those are something you might see. I'll get into this drainage layer behind these walls a little later, but some of the features I like to point out here are that drainage layer, and then just the reinforcing, how they're stretching it and laying it out. When they backfill on these, they'll make sure and stretch that reinforcing so it's tight, and is sort of like pre-stressing a concrete beam. It's already seeing the forces it should be seeing in the mass, and so you'll get less displacement that way. Some other of the components that you'll see for these thin panel walls are the filter fabric that is placed over the joints in the wall. That's to prevent soil from working its way out, but it allows water to pass through so that we have a good drained soil material. And then at the top, we'll put a geomembrane. This is common with our thin panel walls because they have steel reinforcing. We want to make sure that the oils and other and de-icing salts don't migrate into the fill and begin corroding the steel reinforcing. So we'll put an impermeable layer there that will prevent that water from the roadway working its way into the fill. And then the component more for aesthetics is the coping, usually a precast coping, but it can be cast in place. And that just goes on top of the panels and gives it a nice finish, nice look at the end. So one question I ask, and I know that no one's unmiked, but just think briefly, what part of this, from this discussion, what part of this would be considered then our retaining wall? What is the mass and what is the retained soil? So I'll give everyone a moment to think about that. So with these walls, it's a little different from what we saw with our CIP walls. So the mass is the entire reinforced soil zone. That's your wall right there. It's not the thin panels in front. It's not really the leveling pad. It's the reinforced soil mass. So this is your wall. And then everything behind that is your retained soil. So this soil is trying to push over this wall mass. And again, it works much like the CIP walls, in that the weight of this mass is what keeps it from tipping over, what keeps it from being pushed out, and what keeps it from, and then the size of it sort of distributes that load and will keep it from settling too much. But these walls are a lot heavier. But they can also withstand a lot more settlement. So we typically do see larger settlements with this type of wall, although we still try and restrict the overall post-construction settlement to about 1 inch. So just some other items you might see on your projects. You've got slip joints. So that's placed in portions of the wall where you might expect some differential settlement just to break up the aesthetics and make sure that the eye isn't drawn to misaligned panels that may happen. And you also have corner details. Again, this helps break up that aesthetic and make sure that the panel alignment has a little bit of flexibility in it, that you don't have to be perfectly aligned with those panels. So some of the things that are different about this wall is because it is a proprietary product, we have a pre-construction meeting that happens 15 days before the wall construction begins. That should include the project engineer, of course, and the inspectors. The contractor will be there, and the MSC subcontractor, so whoever is really building the wall. Sometimes it's the general contractor, so that's optional, but most often there is a subcontractor building the wall. And then you have the MSC wall system supplier. All these parties come together to make sure that everyone understands how the wall goes together. By that meeting, you should have several items. So the contractor, by 15 days before the wall is going to be constructed, is going to have a complete set of plans and specifications, which is given to the wall designers so they can design the wall. And so that'll include the fader and anything else needed to design that wall. They should have certificate of compliance for the materials of the wall and the test reports that certify that compliance is real. So those should be something that the contractor gives at that time or before that time, so that we know the material we're going to receive is what we want in the wall. They'll also have a construction sequence plan. So how's this wall coming together? And it's going to show several of the features in the wall, and it's also going to show how it's going to interface with abutting structures like bridges or other CIP walls that may need to be placed on the project. The wall supplier is going to have a documented field construction manual. So how do they want their wall built? And they're going to be providing a technical expert, should be there for the first course of panels. And then they're going to be providing shop drawings and calculations, which will need to be reviewed and approved. So who reviews that? Well, you should probably review that, and the inspector should review that. And part of the reason for that is some of these areas are going to be messy. There's going to be utilities behind this wall, and they need to have details for getting around those utilities or those obstructions to make sure we get a nice mat of reinforcing and not a messy rat's nest of reinforcing. So just those things that aren't addressed in the shop drawings need to be caught. And the more eyes looking at those, the better off we are with that product. So oftentimes those familiar with the project will see things that a person such as myself who isn't familiar with the project can't see. And can prevent things from happening. By far, that's one of the biggest problems with any structure is what wasn't seen when the plans were put together. What is going to change that design? But the calculations and the shop drawings are not usually checked by field staff. Those would be forwarded to the engineer of record. So if we didn't put together the plan in-house, if someone was hired to put together the wall plan, they should be involved in checking and making sure those drawings are what they expected to see and meet their specifications as well. I would also be involved. I put the bridge office here because other staff could be involved, but I would also be looking at those calculations and shop drawings and making sure that they meet our specifications and that everything makes sense from a structural standpoint, that they did everything they should. And then of course there's a foundation review to make sure it's compliant with the bearing loads they're putting on the soil, that what they use for their assumptions of the in-place soil properties makes sense, and that they've established exactly what needs to happen to that in-place soil. So we've got a spec that of course should be reviewed by anyone involved with the construction of the wall. And then the shop drawing should be reviewed for compliance with those specifications. So making sure that everything has been appropriately dealt with. You should make sure that you're confirming you've received those certificate of compliance especially for the backfill material, but for all components of the wall. And then confirm that the fill material has been tested and approved before it's brought to the job site. Be terrible to bring in a mass of soil and not be able to use it. It's a huge expense to everyone and waste time. So because that's the major component of the wall, it's one that should be closely watched. So before I move on to PMB walls, and is there any questions about MSC walls and that construction?
Not seeing any more other than that one you already addressed.
Okay. So yep, I'll continue on then. Precast modular block walls.
There is a question just came in. Are those piling in the pipes?
Oh, yeah. So back here, yes, this is a bridge abutment. Sometimes we'll case our piling. That's determined by the foundations office at this point. So if the geotech says, who does the fader report, that, hey, we're going to see a lot of settlement or some sort of down drag load on these piling, we should case them, then they'll be cased. And we do that a lot. So yeah, they'll drive the piling, put the casing over them, and then they'll build the wall around the casing. A good question and a good catch. I probably should have addressed that, so appreciate that question. Precast modular block walls are another thing that we deal with, and it's another oddly complex wall system because it is proprietary. Aesthetically, these are well liked because they look like a stone or a cut wall of some sort. And I've never had any problems aesthetically getting these through on a project, but the big problem comes in with the supplier and making sure that we get the design criteria well established. But when it's done appropriately, you get a very nice end product. So why are they called prefabricated modular block walls? Basically, these units are cast or concrete, they're precast concrete, and they're a modular system. There are a lot of things we want to be aware of with these walls, and we usually do that in design. So this wall, we have a metal railing on top. It's not common to do that because there are issues with the connection of the metal railing, but it can be done. Oftentimes I recommend that it be avoided because of those issues, but sometimes you just can't get around certain things. But aesthetically, people really like them. So you see them around the metro area particularly, and I've seen them in Duluth all over the place. We classify our walls by height and by whether or not they have soil reinforcing. So we call them phase 1, 2, and 3 walls. Phase 1 walls are just gravity walls, so that's just the block, and the weight of the block itself is what is resisting the load. We don't allow gravity walls above 8 feet because this is a modular system. Those blocks can begin to slide, and above 8 feet, they don't respond very well. The weight of the block is just not massive enough to resist the loads that it's seeing. For phase 2 walls, we allow them slightly higher, 2 feet higher. The phase 2 walls are reinforced walls, so they become an MSC structure. And are treated much like our MSC structures would be. Phase 3 walls are also MSC structures, but they're just a more refined engineering analysis that goes into them. We look at the designers that are for these systems, they submit them, and we make sure the designers understand our construction requirements and our design requirements, and then we make sure that the product meets all our environmental requirements, all our prefabrication requirements, and that the grids and other items that they're specifying meet any product specifications we would have. And then we approve that wall as to be supplied based on the materials and making sure that their engineers for the supply understand the design process and the restrictions we have. So any wall you see on our projects, particularly and on most local projects, will come from this list that we have for these walls. So since I've already gone over MSE walls, and the PMBW MSE walls are very much similar in how they work, I'll be going over mostly the gravity walls just to highlight the difference between CIPs and the MSE and these walls. But these walls consist of the facing for the gravity walls, and then of course the retained soil behind them. And so mostly you're looking at the mass of the blocks resisting the load from the retained soil. These walls will also be buried 2 feet, and then the leveling pad underneath the blocks that is placed there is 2 feet thick. Again, we don't want frost heave to cause the facing blocks to displace and ruin the look of the wall. So we want to make sure the leveling pad's deep enough to prevent that from happening. But I'll show us a typical section we have. I'd show this first one mostly because this is what those walls will look like in cross section. And I think we developed this as a generality. It's sort of misleading. You would see more of a triangular shape because you'd have larger blocks underneath these smaller blocks for a taller gravity wall. But this leveling pad then sits down underneath. They are welcome to make that leveling pad as thin as they want. So in these walls, we say 6 inches to 2 feet max. But typically what we're seeing is 2 feet because it's easy to do and it's cheaper to do. And then they set the blocks on top of that 2 feet thick leveling pad. The blocks then are supplied, the shapes are different from wall type to wall type. Behind those blocks, we'll see a drainage layer, just a foot of coarse aggregate, so sort of almost like a French drain that allows water to be drained out from behind the wall, so you're not seeing that hydraulic pressure in the design. And then you have your backfill soil. Again, it's that same 3149.2.D2 material. That backfill material, depending on where what the in-place soil is, may be placed at a 2-to-1. Typically, we're seeing closer to a 1-to-1 in the excavation of these. When we estimate prior to letting a project, we estimate using the 2-to-1 because we do that for all of our walls, but the excavation may actually be wider than 2-to-1. Most often will be wider than 2-to-1. And so you have that retained fill. It also will drain out through this aggregate layer. And then we have this, it's steadily getting larger, but this 4 feet shelf in front of these walls typically that will be seen. So that's basically a gravity wall, again, a mass, and then the retained soil pushing on it is resisted by the mass of those blocks. So the contractor provides much of the same items that would be provided for an MSE wall. In fact, I just copied this over and I forgot to change MSE here. But it's the same thing. They're going to be showing exactly how that wall is going to be put together and providing a certificate of compliance for the material to make sure that it meets our requirements. if this should be an MSE wall, which it can be, again, that material becomes very important, that backfill material, and a pH limit is put on the material to prevent degradation of the reinforced, the soil reinforcing. So that all that will be supplied and it should be supplied a minimum of 15 days before the construction of the wall, and to make sure that those are received. And again, there's going to be a wall supplier. They're going to provide this field manual. They're not going to have, since these walls aren't super tall, they're not going to have a expert on site. But they will still be providing shop drawings and calculations for review and approval. And much like MSE walls, those will need to be forwarded to whoever the engineer of record should be, whether that be an in-house project or if they hired an engineer to put this together. Our office then looks at them. Typically that goes through me, and then the foundation's office will need to review and for compliance as well. So those need to be forwarded. The PMBW spec is very similar to the MSC spec, but there are differences. So you should be familiar with those special provisions. And then again, you're more familiar with certain aspects of the project. So just looking over, making sure the specifications are being met, making sure that the utilities that are in the area have been dealt with whatever details they have, that you have been receiving the certificate of compliance for the wall components, and that the fill material has been tested and approved appropriately according to whatever the special provisions say. I will say at this point, because these are prefabricated units, and also the thin panels of the MSE are prefabricated, those are reviewed in the field just for general damage that may occur through transportation, but someone is inspecting them at the plant as well. So I think that helps the process, but of course these units should be inspected in case during transportation they were damaged and are no longer compliant with the specifications. So that's pretty much precast modular block walls, and I'll actually get back to them in a moment. But before I move on to soil nail walls and those components, are there any questions about precast modular block walls?
Seeing no other ones.
Okay. So soil nail walls are the last, I'm calling it common because we do see them pop up one every couple of years. Wall type I'll go over in great detail. Components of soil nail walls are a little different, and how the wall performs is different from each of the wall types we've reviewed to this point. To me, I really enjoy soil nail walls because I just like to see the engineering come together, and the components of a soil nail wall, they're all basically the same. Here I'm showing the shotcrete face that you have on a soil nail wall, the soil nails, which then have this plate that bears against that shotcrete face, and then you have these drains that go behind the facing, and of course you can see the wire grid that's used in the shotcrete. This particular wall, and I dug for a final product, which I unfortunately don't have, but it's going to have a cast in place wall face. And that's why you see these studs on the soil nails. So how does the soil nail wall work? It works a little different from what we've seen before. So with MSE walls and with CIP walls and the precast modular block walls, these are all cut walls. You cut the section first, and then you place the wall. And this particular wall, it's a top-down construction. So you're not you don't take the section out first, but as you're digging, you place in the soil nails and the shotcrete face in stages. And then once the wall's together, you cast the face on the wall. And they work a little differently too. So this soil wants to push out. And so you have a failure plane in there somewhere. And there are several failure planes, and I won't go into that in too much detail. But that failure plane then wants to push forward. It's going to want to fall down and out from the face. And the soil nails are then embedded far enough into the existing soil beyond this failure plane um, so that they can provide a force that resists that outward force. The downward force is not a huge issue. There's ground there, and so it's going to ultimately go where it went before. But the outward force is what you're trying to resist with soil nails. Typically, soil nails will be angled down at about a 10 to 15 degree from the horizontal. But that's really how they're functioning is that soil nail pulling against that mass. And pulling is not exactly the right word. These are not typically post tension, but as that mass shifts this a little bit, then the nails are engaged and they're resisting that load. But as you excavate, so as you're cutting down, this a top-down construction that you have, this cannot be left open very long. And so in the field, they need to make sure that the construction schedule is very strictly followed. Because as you excavate, that soil will sit there for a little bit, but due to vibrations in the area, and just because as the soil will either dry out or change, conditions change environmentally, you're going to get that soil sloughing. So you want to get the nails in and that face in as quickly as possible as you're doing those stages. And in this case, they didn't exactly do that. And so you'd see something like this. This is not what you should see behind a soil nail wall when it's properly constructed. You have voids that are now going to have to be filled, and the design of the soil nail wall may change. So the construction schedule needs to be strictly adhered to. And if there is any reason why there's a delay, there needs to be a plan to keep that face from sloughing. What are they going to do to keep the soil from escaping and from changing the design of the soil nail wall? So you're going to see shop drawings and calculations for review and approval. What are they providing shop drawings for? Well, the soil nail itself. We provide a load on the soil nail, typically the designer will, and we provide the shotcrete facing and how thick will that be and how is that reinforced more or less. And then we provide a permanent facing if it's a permanent soil nail wall. Those details are provided by the engineer of record. But the soil nail is proprietary, and there can be many different types of soil nails. So they need to provide a shop drawing showing the placement of those soil nails and calculations showing that that soil nail meets the requirements that we specified in the plan. So that's what we'll be reviewing and approving. And again, that would be reviewed by the foundations office and our office and the engineer of record. Should take a look at those, whether that be internal or some other hired consultant. And then they're going to be performing a performance and proof tests on these nails. They're going to have that in a report that needs to be documented. So that's something we would expect to see for this type of wall. The engineer and contractor should inspect the site. So the contractor has the expertise, right? Or has hired someone who has the expertise in placing soil nails. Inspecting the site can avoid any problems so that as they're excavating, they know what they're going to have to deal with. And if there's any problems with the wall and how it's designed, those can be caught prior to digging a hole in the ground and finding that you can't even build this wall. So it needs to be done prior to construction. and document the site conditions. And this is a safety measure because, as we all know, claims may come through. If site conditions have been well documented, everyone should know what to expect. And then there should be a reference list. In most projects, the contractor needs to have a design engineer for the nails, and whoever is operating the drill rig, who is installing the nails, basically, should also be documented and received. So those are the submittals you would expect to see with those walls. So before I go on, and this last part's going to be really quick, but before I go on, are there any questions about soil nail walls?
No other questions, and we are running behind, so yeah, just blaze through these last few.
I will blaze through this. This is really short. So modular block walls, and the reason I put this in here is because this is not covered by the bridge office. These are purely a foundation item because they're more of a reinforced wall, a reinforced steep and slope. This is what they look like. This is the difference between what our office is in charge of, precast modular block walls and modular block walls. A lot of times I get a call for modular block walls and I have to redirect them. And this is just hoping, now that you know the difference, if you see a modular block wall, you can contact Foundations. Rich Lamb or Blake Nelson over there would be able to help you. Same thing with reinforced steep and slopes. Those look like an MSE wall. I get calls on them all the time. I really can't help because this is a geotechnical engineering thing. So this is a standard plan. They can answer any questions you might have. For any other wall type, and there are many out there, basically they fall into those zones of these more common wall types. So they may be an engineered structure, in which case it's just like a bridge plan, because someone engineered it and someone told them what to use. Or they'll have components that need to be engineered by the contractor, and we've given them specifications. So they may have ground anchors like a shoulder pile wall. Sheet pile walls will give them components, and then the contractor give them requirements for the components of the wall, and then the contractor will supply something, and then it'll need to be reviewed to make sure it meets those requirements. But by and large, they're much the same as many of these wall projects. Each component that is similar from the walls I've discussed would be designed and treated the same way as those wall types. And so with that, that's all I had. It sounds like we're running behind, so I can go ahead and cut off at that point.
Yeah. So thanks, Joe, for sharing all your knowledge on the walls. I don't see any other questions in the chat box. So let's just take a little stretch break, 3 or so minutes while we fire up. There'll be a little, another one on project lessons and claims kind of a thing. Then we'll take a little longer break before we wrap up for the day. So just a 3 or 4 minute break now. Okay, first day we did a little exercise, project example, kind of a claims thing, what people can run into. Here's another one that hopefully this will also generate a little bit of interest. Again, like the first time, we'll monitor the chat box, see what kind of thoughts you folks have on the example that Andy's gonna go over. So we'll go over this in a little bit of detail, and I think at the end, Andy will explain what the project came to at any rate. And so with that, Andy, take it away. And then for the class after this, we'll take about a 10-minute break before we wrap up for the class. So go ahead, Andy.
All right, thanks, Paul. Well, afternoon, everybody. I'm going to give you another example of a claim or an issue that went on in the project. So, and then how this project encountered this situation with cold weather concreting. I won't go into great depth or details, or I'm not going to point fingers who's right or wrong. So again, we'll just do this short and sweet, and you guys are free to chime in with questions, comments, whatever. So on this project, it was let on October 27th, contract duration from April of 18 to June of 2020, New Ulm, Minnesota. It was a consultant design project, MnDOT administered. The bridge number is 08016. It's a 5-span river bridge over the Minnesota River. The piers are on drilled shafts. Abutments are on H-piles. It's got 54-inch by 112 beams. And it has post-tension ducts in the pier caps for future widening of the bridge. So the project overall included 3 bridges, with 2 of them significant in size, some grading work, 3 roundabouts. The bridges were subcontracted out to a bridge building company for construction of all 3 bridges, with a total contract value of $31.5 million. So just look at some details here of the bridge. It's over the Minnesota River, 5 spans. It carries 2 traffic lanes, nice 8-foot shoulders, and a 12-foot multi-use trail. And for those of you that know the Minnesota River, this is considered normal flow, and it is prone to flash flooding very frequently. So here we can see our pier on drilled shaft foundation. There is some aesthetic value, but nothing overly complicated. Here's our post-tension ducts in the pier cap they're cast into the cap for future widening. So now we know some of the bridge details. Let's look into the issue of the concrete placement. But let's look at the cold weather spec of 2401 3G for 0.5. So protection against cold weather. All the forms, in-place concrete, reinforcement bars, top flanges of beams, everything need to be preheated to a minimum of 40 degrees when the air temperature is below freezing before placing concrete. Not allowed to use flames directly to concrete or steel. Forms must be insulated. If needed, heat and housing of the entire area to be poured and maintained between 60 and 120 degrees during the curing period. The engineer may allow a concrete surface temperature of between 50 and 120 degrees for concrete strengths equal to or greater than 6,000 PSI. So on 1512, unacceptable unauthorized work. We talked a little bit about this before. Work and materials that do not meet the requirements will be unacceptable. Unacceptable work resulting from poor workmanship, use of non-conforming materials, damage through carelessness, or any other cause existing before final acceptance of the work. The department will take one of the following actions at the engineer's sole discretion. So the engineer can direct for the contractor to remove and replace the unacceptable work or correct the work at no additional cost to the department if the contract item does not meet specific requirements. So our scenario for the pier cap. On February 5th, pier cap concrete placement. Outside ambient temperature is 6 degrees. The formed pier cap has insulation blankets on the top side only. Contractor alleged preheating for 12 hours prior to pour schedule. Foreman states to the inspectors, the formed pier cap is clear of obstructions such as snow and ice, and it's warm enough inside the forms to pour. So the concrete is ordered. So If you were the inspector, what would be your next step? Let's play a little scenario here of choose your adventure. So with our knowns we went over, would you take option 1 as the inspector to walk up the staircase and verify the pour placement area meets all the specifications prior to concrete placement? Or would you head, as one of your duties as the inspector, head to the concrete plant first, then come back to the project, test the concrete before the concrete is placed into the forms, and then do your pre-placement inspection? So if you choose option 1, walk up the staircase, verify the pour placement area meets all the specifications prior to concrete placement. So on your journey up to the Pier Cap, you take along a temperature gun to verify that all the forms, rebar, and adjoining concrete surface meet or exceed the requirements set in the specifications. You do the hands-on inspection to verify what the contractor had told you. So during your inspection, there's no insulation on the outside of the formwork. Again, only a blanket on the top. So we pull open the blanket to look inside and verify adjoining concrete and rebar temps. Upon internal form investigation, you notice there's snow and ice buildup on the inside of the formwork. We all know that 32 degrees is freezing cold. But our minimum temperature requirements are not met prior to placement. The lack of heat and housing to maintain concrete temps are not in place. So none of the specifications have been met. So the Mr. Inspector tells Mr. Contractor his minimum requirements have not been met and you are not allowed to place concrete at this time due to not meeting the requirements per the specification. So if you chose number 1, we're good until this is the end of your venture, because we know the contractor has to take remedial action to get his formwork and everything up to par, preheating, and then also to maintain heat temperatures for the curing time. So with this stopping now, it allows the contractor to get into requirements. So if you chose option number 2 as the inspector, again, one of your duties is to go to the concrete plant, sign the first ticket, verify weights at the plant. Then you have to beat the concrete truck back to the construction site to inspect and test the concrete for passing results before placement. After the inspector tests the concrete, he goes up to the Pier Cap location to observe concrete placement. By now, there's already 1 truck, if not 2 truckloads into the Pier Cap. The inspector notices there's snow and ice buildup inside the form when he arrives. So Mr. Inspector informs Mr. Contractor to melt. He needs to stop pouring concrete, needs to melt and warm up the rest of the form area to remove the snow and ice. So after all that's done, placement of concrete continues and is completed. In the meantime, thermal pucks were put in place to monitor the temps. Now let's underline, because this will come up later on. So remember, this is back in February. Thermal pucks were put in place. So a week or so later, forms are removed. It appears there is unconsolidated concrete or honeycombing at the bottom of the area, bottom of the formed area. You can see in the pictures here, the little cracking, honeycombing. Well, on the bottom, on the bottom side, the rebar is exposed. Where did the concrete go or not go? There's plenty of area between the rebar that the concrete should have made it to the form face. And you can see it's on both sides of the Pier Cap. So on the Pier Cap, 27 days, MnDOT broke some cylinders. They're 800 PSI short of the 6,000 PSI requirement. So MnDOT requested the temperature puck readings. In the meantime, MnDOT has an internal meeting discussing the concrete placement. Attention came to concrete may have been placed on snow or ice. Engineer of record and the MnDOT specialty office were contacted for a site visit. The site visit determined the issue was more substantial than unsound concrete. So here we can see they chipped away all the loose concrete, and what's exposed, supposedly a superficial segregation or honeycombing. Here's from the bottom side looking up. And remember, this goes around this end, this side, around the end, and up the other side. So MnDOT believes the concrete could have frozen. Inspector has the conversations with the contractor of concrete being placed on snow or ice. But then how do we determine if the concrete is frozen? Conversations were had between the contractor and the department of remove and replace. But that costs time and money, and who's going to pay for it? Agreed upon to cut cores to verify concrete strengths in place. Again, the concrete mix was anticipated at 6,000 PSI. And according to ACI, American Concrete Institute, cores need to be 85%. Well, the cores came back at 86.4% of the strength. And the cores were taken in the warmest spot or the best area of the concrete. Think about, what would you do at this point? Would you just repair the superficial defects or do a complete remove and replace of the pier cap? So letters and meetings back and forth between MnDOT and the contractor until June. So we're 5 months later. Contractor keeps implying that it's cosmetic. There's no need to remove and replace. It was proved further by testing by a third party on the contractor side that it was good concrete. MnDOT states requirements were not followed or met for cold weather concreting. So on July 1st, a project meeting is called with the MnDOT, prime contractor, the subcontractor, consulting engineers, and all parties involved. At this time, the temperature readings are disclosed. Remember, this is July now. The concrete was placed back in February. Why were these not disclosed earlier? Results of the temperature readings from the pucks at the time of concrete was 10 degrees. So some few more considerations to add is the pier cap is built to accommodate future widening with post-tensioning. Some concrete was placed on snow and ice. Spec 2401 for cold weather concreting was not followed prior to concrete placement. Is the pier structurally okay? The field staff is just not comfortable of the way it turned out. What are some other considerations? Type them in the chat box. Thoughts, considerations, feelings. What do you think? We remove and replace. What would you do in this circumstance?
You able to see the chat box, Andy?
Yep, I got her up now. So
Okay.
we have one person move and replace. Good point. Interesting dynamic with between MnDOT, prime, and sub. And why is, on that note, why is MnDOT dealing with the sub? MnDOT should be dealing with the prime. They have their contract with the prime, not the subcontractor. A lot of remove and replace. Of course, we're taking in warm and best spots. It would be good to see a core and strength near the 10-degree puck. Did MnDOT allow the contractor to set beams on this pier cap? Well, we haven't got that far as setting beams. We're still deciphering what to do with this pier cap. Remove and replace at contractor's expense. So this is all good points, good valid points. We'll keep going here. Show you what the project did. Kind of covered all this. What would your resolutions be? We had a lot of remove and replace. Some other extra coring. So this was the project's team's resolution. A third party was hired to determine if the concrete had frozen. So now this was brought up in a chat to check the concrete in the frozen area or the honeycombing area. Test results confirmed that the in-place concrete was frozen. Contractor did place concrete on a frozen substrate. So the department tells Mr. Contractor, you need to remove and replace the pier cap at no cost to the department. So midsummer rolls around, you can see the green leaves back on the trees. So we're into July, into August, and removal begins. So, but just a note, remember this was poured in February and it's July, August before we got around. So it was a lengthy time period to investigate the root of the problem and execute the solution. So now you incur time delays, all kinds of scenarios. So during the removal process, MnDOT documented the entire process, doing daily photos, written and video documentation, and actual samples of the in-place concrete. So as the inspectors dug deeper into the pier condition as the removal process was ongoing, you can visually see here that it's just not 6,000 PSI hard concrete. Pretty crumbly. So then Mr. Contractor files a claim with the department saying it was unnecessary to remove and replace the pier cap. All the defects were superficial and could be repaired. They are asking the department to finance all the costs associated with remove and replace at a value of about $173,000. So, some lessons learned by the field staff. Better due diligence, physically confirming appropriate temps prior to placement. Better time management, confirming proper minimum requirements are met. And contractor, MnDOT, inspectors, engineers, they're all in it together. We've heard about partnering, it's a big thing. Project meetings are crucial for effective communication. Trust but verify the contractor. So that was the quick down and dirty of that scenario. Any questions, comments, how that was handled?
Any other questions for this one for Andy?
Oh, and by the way, that was the end of Adventure 2. So we know if we could have solved the problem right away, it would have been cut and dry, taken care of right away. but where you can see we went on track 2 and it was a long drug out process.
Okay, well, thanks, Andy. I'd like to take a 10-minute break and then we'll get back. We'll finish up Paul Pilarski's and then we'll have some closing remarks, open forum discussion if you can have anything like that. And then there's a final Mentimeter little quiz. So 10-minute break. So I'm showing 3:03, so 3:13 reconvene.
So there's one question that came in here is what happened to the claim? The claim is in the legal office at this time, so we don't know the outcome yet.
Okay, thanks a lot, Andy.
Yep.
To wrap up, Paul Pilarski is going to finish up with some of the repair things that he didn't get to this morning. So
Yep.
Paul, take it away. And then after that, we'll have some closing remarks and a final little quiz type deal.
Sure. When I last left off, we were talking about concrete surface repair, shotcrete, and now we're going to get into shoring. The top 2 pictures are an existing bridge that we were scoping for a bridge redeck. So it would be a project that we wanted to get 30 more to 50 more years out of. This is what it looked like, the top 2 pictures and scoping. We can see that it's been previously repaired. And during construction, the below 2 pictures, we recognized when they started chipping on this that all that previous shotcrete kind of fell off. There was a lot of new corrosion, and it just wasn't suitable for saving. So we ended up replacing that Pier Cap by change order. And it really initiated our thoughts on the need for shoring and better scoping after this 2015 redeck. So we are making better attempts now to understand Pier Cap strength and when we need shoring. And so if you've got a project with concrete surface repair on Pier Caps, you may also have shoring identified. And we approached contractors with this bid item and asked them, how do we best manage this situation? They said, well, we do want to know what sort of shoring we want in there, and we want to know what we have to allocate for engineering time. So we agreed that we would try to identify all the locations we want shoring on the bridge. It's going to be a lump sum. And we're going to classify what we think the shoring type is there at each location. So each beam gets identified, each beam end for where it needs support. And then there's a matrix for the submittal requirements associated with that shoring complexity. So shoring type E is the least complex to type E there's pretty complex, so there's more submittal requirements. So in the special provisions, if you had shoring on your job, you'll have the location, the type, the dead load reaction, and the support purpose. And that's key, because if we're repairing an element like a column or a Pier Cap, we don't want that shoring removed until it's repaired. It has to stay in place until the concrete strength has been achieved. So here's what a type A might look like. It's just cribbing on top of the Pier Cap. There is a reliance on our Pier Cap for that. A type B would be some engineered works, but also, again, reliant on our Pier Cap to support the beam. Type C would be a commercial fabrication. So there's published values for how much these components can support. And we require a lesser degree of engineering submittal for those. Shoring towers, they are also a type C classification, but those elements above the beams that support the girder and the jack and the foundation pads, those are engineered elements. So we would expect an engineering submittal for those components. A type D, you may have a commercial tower, but then it's dependent on our structure for stability. And a type E is going to be dependent on, or have more dependencies on our structure. So in this case, they clamped to the column, it was reliant on the column, and it was bracing the pier cap. So it's a lot more complexity there. And then we saw this on a recent project in 2017. I call it the Jenga shoring, but it was effective, and they were supporting the bridge with the deck on for an entire pier cap replacement. So sometimes we realize that the cost of shoring versus the gains are going to be not as economical. So sometimes we're looking at providing an alternate route for the load to get to the foundations, and oftentimes that's an infill wall, just infilling everything that would normally be a flexural component. So they do have a structural role, and that means they really shouldn't be chipping on the concrete of the original pier cap until that infill wall is in place. There's still going to be deterioration a lot of times underneath the bearing, where again we'll need to bring in shoring to lift the beam off the seat area of the concrete pier to repair that area. So we've had a lot of infill walls to date. It's using self-consolidating concrete and a form that fills up the space between columns as well as outside the column. And there's a lot of adhesive anchors, but there is a sequence for this. And a lot of times the pier cap is getting this infill wall because it's in bad shape. So read the sequence notes, remove loose concrete only. It's not like a concrete surface repair where you chip to sound concrete. These are sensitive areas. So we just want to chip to the loose stuff away and don't chase it. Sandblast the steel you've exposed and then get the infill wall in. And it doesn't matter as much if there's deteriorated concrete behind those bars, because we're essentially using concrete as a wall, like a masonry wall. And the internal concrete in the cap becomes almost like bricks. So the integrity isn't as important. We just got to get that wall in as a vertical support. So that's the message on those that read the sequence for infill walls. There's a lot of other slides on that topic in your handout that I'm going to pass over, but I'd encourage you to look through the full handout because this is all specialized work, and when you get on your job, it's nice to have some background. Cathodic protection is some of the most misunderstood items in our rehab work. It's basically zinc embedded in a mortar shell. Oops, it looks like I gotta change my timing. Sorry. Okay. So it's zinc and metal mortar shell that makes that zinc want to corrode. And there's wires sticking out of there that hook up to the reinforcing steel. So instead of the steel continuing to corrode, you get the internal zinc in that mortar shell to corrode. There's other anodes out there. There's this distributed anodes and metallizing. So this, what you're seeing in the picture, is a puck anode, we call it. They have different shapes out there, but basically a small discrete anode is what I'll call a puck. The challenge with cathodic protection, or including anodes, is that we have a hard time understanding how many we need at time of bid. So we'll give a quantity in the plan so that the contractor can order materials ahead of the job. But that means when they mark out areas after sounding the pier cap, there's going to be some field interpretation of where these anodes will go. And they may look to you to understand and direct them. The contractor does not typically want to be in charge of locating these anodes. And as a result, in the past, the installations have not always represented the best use of our money for placement. So what is some of the considerations here? Well, if you put in a puck anode, basically there's what's called a throw distance. So there's an area of influence about a foot radius. If you drew a spear, put the anode in a spear, it could reach out a foot from the anode and prevent corrosion. the level of protection is related to how much zinc is in that anode. So that's the thought of when you go out there and look where to place these. You really only have a foot of influence. Also note, a fully exposed rebar does not need an anode. What the anode does is it protects rebar that's still in a chloride environment. And when you've chipped all around the rebar, you've removed the chloride. So we find that there's lower concentrations of chloride in the native concrete because it hasn't corroded the rebar yet, but it will be a site of future corrosion. So we want to locate the anodes near the boundary where the steel goes into old concrete that's not removed. In the past, this bottom note, contractors are bidding very high prices for these things, thinking that they had to carve out these pockets, and that labor to carve out a pocket is really expensive, but it's really not necessary. They could simply attach the anode to the steel and embed it in the concrete repair and just provide a 1 inch of shotcrete over that anode. The challenge is that I'll get to in a little bit, I guess. So let's look at a placement of the past versus a better placement. So in the past, they chipped away this column that was in the splash zone for plows, and they're going to shotcrete this back. They threw in the anodes behind the steel, where they really aren't very effective. If you think of that radius of influence, the steel as it enters the old original concrete's where we want them. So they should have relocated these anodes to the exterior of your repair boundary. And the exact form of the column, whether it conforms to the true shape, we could bulge that out a little if we need to get the anode placed. So while I'm on the topic and we show some horrific columns, anything wrong with this picture? Yeah, if you fully expose the column perimeter, you're definitely weakening that column. So when your inspector has painted up any column repairs, if they're going to be chipping around the perimeter, we better get an evaluation in the bridge office, whether that's a safe operation. We might need to do it in stages so that reinforcement on the compression side of the column or flexural side doesn't buckle all the way. So this particular location the bridge was really restrained. It was more pure axial in that case. So I said you really don't need to put the anodes behind the rebar. But if you were just to shotcrete over the anode, it doesn't give it a good bedding. And how the zinc gets current, there's actually electrical current given off by having zinc next to steel. You need to have good concrete and to make a continuous path. And the current is determined by how much resistance to electricity or electrical flow there is between the zinc and the steel. So we want a low resistivity bedding for these anodes for that area that's in contact with the old concrete. It's a hard concept to get, but that's the best placement practice, is that you butter up the anode with a low resistivity mortar prior to shotcreting over the whole repair, and limit how much of that low resistivity mortar you actually use. So that is one form of anode. There's also an external anode, just like a paintbrush, they spray it on the surface, and they're spraying the surface with molten zinc or molten metal that then gives itself up instead of the steel inside the concrete starting to corrode. So just like you galvanize your bumper or whatever, you're putting a metal that wants to corrode faster than the metal you're covering. But in this case, the electrical action happens through the concrete. So that's a welding type operation. The zinc wire comes on these spools for this type rig, and it comes out 2 nozzles. And then there's 3 compressed air nozzles underneath this handheld hood thing that sprays it. And then when those 2 wire spools kind of contact with this high current, it vaporizes and the compressed air blows it onto the concrete, and it's adhered. So in order to prep this, they're supposed to sandblast the concrete really well, and then that sandblast only lasts about 72 hours at the most. So they should do that just ahead of the metallizing operation. And before they do that, they need to have some sort of connection to the internal steel in the concrete. So sometimes they'll tap into it with a little threaded rod after locating it with GPR. Otherwise, if it's in a concrete repair, they'll clamp a wire to it and run the wire outside the concrete. So in a cross section, you got this red wire, and they can do a hose clamp or something to establish sort of electrical connection to that rebar. And most of the rebar inside is all tied together, so it's all electrically connected. And then they run this wire outside the concrete repair, and then they clamp it after they spray the concrete with this thermal spray coating or this exterior anode. So in the bottom right, that is a picture of a surface, a concrete surface that's been sprayed with this metallizing. And then they have this zinc mesh that's bolted to the surface and just becomes like the battery terminal. So it's an interesting system. It crosses over to chemistry and to electrical engineering, but it will protect the internal steel, anything behind that metallizing. This stuff, when it's subject to the atmosphere, will corrode faster, which is good for current output, but it's not good for longevity. So whenever we have metallizing, they spray a protective top coat on top of it that's breathable. And we can help you with that with the submittal if they propose something, but just know that you just don't spray and walk away. There has to be a top coat. The next topic is adhesive anchorages. You know, we anchor a lot of things or post-install anchorages, and we can anchor rebar, we can anchor threaded bar for attaching ornamental rail. But there's been many changes over the years due to a result of construction quality, and quality meaning that they drilled into concrete, they hit the first rebar and said, well, I think that's good enough. And then they'd cut the threaded rod short and just glue it on there and say it's good enough. And it isn't. It's not good for getting the strength out of that connection. So we do have for railings of concrete barrier that we want to set the rebar to miss the post locations before pouring the barrier curb. There's many uses for anchored rebar, not just the threaded anchors. So a lot of times we'll replace a barrier on a bridge with something that meets current standards. So that would be epoxy coated rebar that's anchored. In this case, some of the submittals required is that we need to know that those installers are ACI certified, so they should be submitting those forms. So you need a copy of each installer certification. I don't know if it's a card so much as just a printed screenshot that they passed their certification. And then they should be getting a form with a listing of all the people on the job that'll be installing anchors, and then a copy of the manufacturer's printed installation instructions. We really only want one adhesive on the site. It'll create confusion otherwise, and the contractor can go to our APL for concrete adhesives for structural applications. So this is a form. It is on our website that we want the contractor to fill out, give to you, saying who is going to be installing anchors on your job. The installers, there's some basics there for adhesive anchorages that they're required to check the depth of the hole, the diameter, of the hole that they're drilling, the condition of the hole, is it really smooth or rough? And core holes are not as good as rock drilled holes for roughness. And so certain epoxies might not work in those. Cleanliness, that the hole must be clean, dry, and dust free. So if you were to use a paper towel and put your finger on it and put it in the hole, you shouldn't see dust. And then the concrete age, we want that concrete to be at least 14 days old. It happens as concrete takes a long time to hydrate and use all the moisture. And so we found that adhesives do not like concrete that still has moisture in it. So in quality control of adhesive anchors, we've provided 2 paths. There's a pre-production testing path and a post-production, or just going ahead and installing anchors. So the ideal, if you're going to do something, is to go in there and test that you know how to do it before you go put a lot of effort at it. So that would be this pre-production. And what that earns them is that they don't have to pull test as many anchors on their job. But option 2 is the option that contractors choose most often, is to continue at risk because they do this work so often and they feel that they know how to do the work. And so they're going to install all the anchors and then live with the consequence of a higher test frequency. If they choose the pre-production testing route, we expect this form to be filled out by the contractor's third-party testing agent and turned into you, and then ultimately turned back to the bridge office. This pre-production test report. This form is on our website. And then they're supposed to sign it. Whoever does that pull test is supposed to sign it. And then you, as a project engineer, are supposed to ensure that you receive this. Again, at the bottom, send it to the bridge office. And we file those with the Record Center, which is now in eDocs. If they choose to go ahead with production anchors or anchors that are going to be in the permanent work, have your inspector watch the installations. They should be choosing which anchorages get the pull test. So if there's anything suspicious, that's where to locate your test. And again, we have another form for production anchorage qualification test. So it's just pull testing the final installation, and there is a frequency specified in your special provisions for those. So what happens if they pull test? Here you can see a horizontal pull test, and they've got this spreader beam so that you're not restricting the movement of concrete against a pull out when you pull on this. But ultimately, the contractor is responsible for the pull test and whether that rebar is embedded adequately. We have not had too many instances or any instance that I'm aware of where the concrete has popped out during this pull test. So it would be an extreme event that we're anchoring in really poor concrete. So in your special provisions, you should have a table like this that gives you the location, the anchor type, and what diameter it is, the minimum embedment, and the pull-out strength. So read those provisions. If you got questions, don't feel afraid to call us and ask for interpretation. And this thing is something filled out by the designer. So sometimes they get it wrong, and we want to correct that in the plans and get a revision out there. We've moved on from 2012 era to today with a lot of changes in adhesive anchors. And one thing that was noticed in 2017, I think, is that manufacturers really didn't give values for epoxy coated steel. What the strength of their adhesive is on epoxy coated steel. And when contacted, they said, look, we don't do testing on coated steel and we're not going to guarantee it. So in 2017, we were all up in arms, what does it say about us as a state if we've been anchoring epoxy coated steel and we don't have a manufacturer abiding by their test values. So we have changed up the way we pay for anchored reinforcement. And so you'll have all these pay items now, and we don't allow coated steel where it's going to be in a high demand for tension. So we're using stainless steel bars in the front of the barrier because that is a tension bar when it's going to be a long-term fix. You may have a bridge that's a redeck or an overlay where it's a shorter term fix, and we may even use uncoated bars because we don't expect the life of that bridge to be greater than 30 to 40 years. So we can live with uncoated bar. So these different situations, there will be a type L, which is a low level of testing. So the table you will see in your special provisions is going to have a lower test rate filled out by the engineer in the office. A high level, there's a minimum number of tests, so 15 tests at a given location. So it's guaranteeing that we have a good installation out there. We even have what's called a sustained tension pay item now, and that's going to be a higher degree of certainty that we want with those. I don't know if anybody remembers, but there was a Boston tunnel that they suspended some concrete roofing panels from, and it collapsed onto traffic. So all these testing requirements came as a result of that dramatic instance. So to sum up, read your specs and make the contractor aware you're expecting these tests to be done and the paperwork to be filled out and turned in. I give our website on this slide for bridge construction, and there's a lot of resources there. This is where those contractor forms are for the anchorage test reports, as well as the installer certification. So that's all paperwork that should be included on those type tasks. The most common issue with most common anchored rebar situation I can think of is either those infill walls or a barrier replacement. So here's some slides on barrier replacement. They have a horizontal undercut saw it's kind of a specialty. They may come from Michigan for this or another outfit that has a blade mounted to a specialty equipment. It can cut very close to the concrete and make short work of removing that barrier. Now here's the saw cut surface. They even have these bigger blades, these 4-foot diameter blades off bridge, and they can cut through a larger section of concrete. There are limitations for how wide a barrier would cut. Here's another picture of that large saw. So it's crazy to imagine the things that we can do out there for bridges and the equipment contractors bring to the table. So this is the saw cut. It's very clean, and if you look, it came off clean. Very precise work, enables reuse of that bridge deck. So this is one line railing that was removed, and we're moving away from those because they don't really meet the impact requirements we've established as of, I don't know the exact year, but they've evolved, and we're into much higher impact requirements these days. So this is another pull test. Pull tests are required for all those rebar. They have to do it on a straight bar. It can't be a bent bar. So that is a challenge that we may have to install some sacrificial bars, but then they're the best install out there. So it's something that we work into the assumptions when we do the testing frequency rate. I've talked about crack sealing when I talked about the overlays and wearing courses yesterday, but that may be a pay item on your job, just to go out to a bridge deck and crack seal. And in most of the state, we pay for it by the gallon, and a gallon covers roughly 450 linear feet. I think Cavisto came up with that ratio. So if there's a dispute on the number of gallons, we can refer back to that coverage rate. District 6, they like payment by linear feet. They like to measure their cracks. So if you're serving support in that area, you're going to be measuring the linear feet of cracks sealed. So that is the seal cracks with epoxy by Chase method. It's a long pay item name, but we're trying to get more descriptive with our pay items so that there's no question on what they're bidding. When that cracking is at a tighter spacing, we're going to be prescribing an MMA flood seal. And we're talking with the districts, they prefer the flood seal once you get a certain density. And that flood seal will get everything that it's squeegeed over. So this is a flood seal operation. You will note the striping, and we really don't want the striping covered up by the sealant because there is a reflective property to the striping. So the best contractors come in with duct tape and protect that and then peel it up after that is hardened. Otherwise, that striping replacement is on the contractor's dime. So that's kind of this slide. And then after that is squeegeed out, they bring sand or rock as kind of an absorbent so that any of that glossy look is not slippery to the cars. We're just aimed at sealing the cracks, not resurfacing the concrete. So we don't want a glossy look to our bridge decks. That's why the sand is broadcast everywhere in the flood seal. If you need to open to traffic, there are products out there contractors use. I think they called this like the flu powder or something, but it's or fluff, and it'll absorb any excess or non-drying MMA sealant. So another couple of products you may see on your jobs are these bridge penetrating sealers. So sealing cracks is one thing, and then reducing the ability for chloride to penetrate the deck is another thing. So a sealer for concrete prevents staining. It prevents chlorides from getting into those pores and working deeper. So sometimes we'll prescribe that as well. And there's two varieties. There's a 40% and 100%. There should be a spot test on the area of treatment 5 days prior so that is it a 1-coat operation or a 2-coat? Typically, the 40% takes 2 coats. The 100% may be good enough with 1 coat because it's so much more solids. The spec talks about 2 coats no matter what. So you'd have to prove it out by your test section whether that can be waived. And then we don't want the deck to be kind of rained on and then come out and expect this silane to absorb. It has to be a dry deck for at least 72 hours. So widening and renovation, that is more substantial work. So we might have a redeck and we want to widen the bridge. Some of the nuances of that, besides the traditional remove deck cautions, are that you may undermine the roadway off bridge. So all of a sudden you're into protecting off bridge assets. So the provision in your package would be some phrasing like excavate, sheet, shore, and or prepare the foundation and place backfill necessary for construction of the bridge. So they have to provide a sheeting submittal saying how they're going to protect what the area they've excavated, the area adjacent to what they've excavated. And we typically don't pay for the temporary works, but it should be included in price bid for structure X. So here's an example of a removal of a deck. The rebar is poking out, enabling the widening of the bridge. The sheeting is there to protect the approach panel from undermining and loss of material. The resident engineers asked that I highlight, what it takes to protect vehicles from drop-offs. There is a memo on this, and there's two tables that are important. There's one that covers unanchored portable barrier, and another one that covers portable barrier. So you'd look at what is the drop-off depth, and if for a bridge, if you're on the bridge, you're going to have greater than 8 feet. So edge of the bridges, this last grade column, and drop-offs greater than 8 feet. So you need a setback, or for greater than 55 miles an hour, you need at least 2 feet behind that barrier of deck, of an anchored barrier, just so that if that thing did get hit, it might deflect and it might go over the edge. So this table kind of covers what you need. And if you slow traffic down, if it's funneling through there, or if it's a low speed roadway, you can get away with at least as little as a ½ foot of setback from the edge of deck to the outside edge of your concrete barrier. So again, here's an image of sheeting. I kind of got this slide out of order, so I apologize. But there is another picture of the sheeting, and it may be protecting slope paving as well. The last item on here, I should never say last because there might be more slides coming up, but there's when you have steel girders, the older steel girders and steel bridges tried to really economize the volume of steel used, because steel was really expensive, right? So they'd come in with thin plates, which are going to be susceptible to damage if you've got an older bridge. Look for those thinner flanges in the existing bridge plans. But they also might have these cover plates. So we're looking down on a deck that has been removed and it's been formed for a new deck, but yet you've got these plates that were welded to the top of the beam or girder. And whenever these what we call cover plates terminate, they become a source of a fatigue crack. They're known locations of cracks. So we never know, because we can't see it before we remove the deck, whether there's a crack there or not. So we do a lot of things to prepare for that, and you'll have placeholder quantities in your plan. So the first thing is the weld inspection. The contractor is bidding a third party to come out and do ultrasonic testing or mag particle testing on these cover plate terminations. So within 1.5 feet of the end of the cover plate, they're supposed to give you a report. Are there cracks in those welds? The next thing is, in response to that report, which you should get and should include in the what you give to us in the bridge office for records, we'll have a weld repair item. So what exact weld repair we do out there, that is where it gets kind of messy. If it's a shallow defect, like a crack within the weld, it may just be simply grinding out the weld. If it has penetrated into the flange, it may be a hole that we drill into the existing girder flange. So the contractor gets paid for that, and we give a quantity of 1 for bidding purpose. So you can see if we've had a lot of locations on a bridge, that would add up in cost, because they're probably going to bid pretty high on that one location. But we think we don't get too many of those used. The third item associated with these is this ultrasonic peening. That is a specialized tool that comes in from Georgia. It's kind of a proprietary thing, but they get paid per cover plate. So for that cover plate you're looking at, somewhere we're looking at one end of it, and there's another end. They'll run longitudinally along the girder, and the other end as well is included in the price bid. And I'll show you a slide of that coming up. And then the last item is a cover plate repair. So if we found a crack has gone into the steel, or then we're going to plate over it and put like a splice over that section. So if that crack continues to work, we don't sever the flange. So here's an image of where the crack might be. This is an image of the ultrasonic peening going on. So we have done it on primarily the top flanges that have been exposed in the bridge deck, thinking that the underside flange, the bottom flange, is generally inspectable. But in the metro where they don't have routine access to interrupt traffic, we're starting to do these as well, just for cautionary sake when we brought in and mobilized the people to do the top flange too. So that this tool has a bunch of needles on the end of it. It operates at a very high frequency. We have a lot of resources on this because it's a specialized piece of equipment. There's actually a whole presentation on the things to watch for. So I'm not going to get into it today. There are some videos that we can give you as a pre-activity meeting for this. But some people are certified in it, and we can look them up online whether they've maintained their certification. Here's a cover plate repair, what that might look like. Comes out with some fabricated plates that are ready to be drilled through the existing flange. So we'll detail up one of these assemblies in the bridge plan for bidding purpose, and then it becomes a field ordered quantity. Okay, so I do believe this is the last section. It's on restriction on movement and storage of heavy loads and equipment. And this kind of originated out of the 35W collapse, that we realized that contractors might want to store equipment on the bridge, and they may not pay attention to what the load rating is for that bridge, or even have an understanding of how much load they're actually dealing with. So this is written in 4 restrictions here. And if you had any interpretation questions, please call us, because this is filled out by the design unit leader in preparing the plan. And there is a lot of times misunderstanding on the intent and what they actually put down, to be honest. But the first line is basically a localized area. Say you've got girders and you've got floor beams, and the smallest element supporting the deck might be a stringer. So that would be a local pile of aggregate on the bridge. And we don't want to have these concentrated loads that might overstress that local element. So you got 1,000 square foot area. Well, I guess maybe that's the medium category, this first bullet. So that might be a floor beam, a transverse floor beam. Number 2, it'd be the stringer. So it's a smaller element, 100 square foot loading area. It'd be for very thin decks or something that can't support, an element that can't support very much. And then bullets 3 and 4 are for the whole span between piers, or between an abutment and a pier. So bullet 3 is no single vehicle or equipment exceeding X number of pounds. And number 4 is no combination of stockpiles, vehicles, materials, anything you put on there, as well as a span length limitation. So if you got a multi-span bridge, it may be just isolated to that particular span. So again, if you have interpretation questions like this one, it came in, this is a brand new bridge. You can still see the overhang brackets on here. And the inspector was very observant and said, that's a lot of equipment sitting on that bridge there. Those pavers aren't light. He had no idea how much these things weighed, but he saw the contractor using the new bridge as a parking lot for all their equipment. And it turns out that that load is probably the highest load that bridge will ever see. It was equivalent to 1.5 times the design vehicle. And luckily, it wasn't moving at speed for the impact, the increased impact, but we had to get the contractor to submit weights for this, haul the equipment off, store it elsewhere. So look for those things. I do have another picture, and it's a painting containment system. So it's surprising that you can hang something from a bridge and not even thinking about it. But painting operations also add a lot of load to an existing bridge. Oh. So on our website, we've got a lot of videos. We got high strength bolting, special surface finish videos, test pile driving, a lot of videos out there. And the link below has some trainings. I can put, I've got a number of videos that, was going to show during this, but they're on YouTube. So the first one I'm going to put in the chat box, and they're not very long. So, so if you click on the link here in the chat box, this was a shotcrete repair to a beam end. So a lot of times people ask, is shotcrete really structural? And if you watch that video, we actually had a project where we repaired a beam with shotcrete that was very, very heavily damaged. And then later we pulled that beam out alongside with one that was in very good condition and tested it in a lab. And we found that the repair performed as good as the original good condition beam. So that gave us some certainty that these are structural repairs if they're done right. There's another series of videos that I'm going to paste in the chat. If you can copy it later to your inbox or something, but this second link is for Hilti anchorages. And it shows how the proper way to blow out a hole is, and if they didn't do it right, how dirty that hole really can be. And then the last, well, I got a third one on metallizing. So if you have an interest in seeing what the metallizing operation looks like, that's what a sprayed anode might look like. And then this project that many of you probably have seen, related to, I guess, temporary works and a lot of the push for accelerated bridge construction. It's the bridge slide that was done in the last 2 years ago now. But there's a lot of partnering with the contractor to get that done, and that was a well-regarded project, and we're looking for more instances where we can be innovative like that. So I did want to be respectful of time and give Paul the time here, but you can look at those videos on your own time, or when to get out of this course at another date. And Paul, that's really all I had, so I can stop my share.
Okay. Thanks, Paul.
Yep.
Good information on all of that. So we are at the tail end here, and there's always, every class we like to have some time for discussion. Let me pull up in the chat if there's anything that anybody came up with that hasn't been addressed. Please feel free to chime in. Paul is probably still on the line too, can help answer if there's anything. So feel free to type something in. A couple of the things that came in on the commentary. A lot of it is we went really fast on some things, and we knew we were going to go fast. 3 days, and we wanted to give at least some semblance of a lot of the different portions. We don't even cover everything that goes on in the 2-week course, but we covered a lot of the topics. So we understand that, and maybe it'd be better to have a few less slides and take a little more time on them. So we'll look for that kind of input for the future. One of them was plan reading. That really would be nice to do a little bit more, because a lot of you haven't been on a bridge project, and it's the first time you've really gone in any kind of depth on a bridge plan. So yes, it would be wonderful to be able to go through it in more detail like we do in the 2-week course, but didn't have the time. But that being said, there is a bridge plan reading online module that is being developed. It's nearly complete, and so look for that in the near future. And I'm not sure, Paul, maybe you can help get that to the resident engineers when that becomes available. I would guess that somehow that link will be shared.
We'll definitely be broadcasting that. They're in their final edits, so it'll be out very soon, and hit your inbox before construction season.
Yeah, so but it's real good. I saw it when I was still back at MnDOT almost a year ago now. They were halfway through or whatever, and there's a lot of good information, and it walks through the same plan, this 27-138, and goes into a little more detail of where do you find this, where do you find that, what does this mean, and so it's a good little module. So be looking for that. The other thing that it's come up in many of the presentations there's a ton of information on the Bridge Office website. So be familiar with that. Mark it as a favorite. I still do that. In my work here, there's a lot of things like the special provisions, for instance, and some of the lessons learned, all that kind of stuff. There's a ton of information. Paul just mentioned some of the videos that are there. There's videos for low slump concrete placement, pile driving, things like that. So it's something that you can look at on that Bridge Office website. Along with that, use the contacts. So you heard from all of the regional construction engineers. You heard from Mark and from Andy. Both of those are experts in their field and are huge help. So be willing to use those folks as resources when you get into your bridge projects. They've all been around. They know the ins and outs, and like when I was in that role, if you don't know the answer, well, somebody else will. Somebody else has had experience. Maybe it's another resident engineer in another district or whatever. But anyway, they're a wealth of knowledge. So use those people. So with that, does anybody else? So nobody's typed anything into the chat box. Paul, do you have anything else to add to the class as we end here?
No, I can reply to all the attendees with videos that we show in the 2-week course, which may be, of interest to the people in this class, but certainly it's not necessary. But yeah, there's a lot of good things in those too.
And it looks like, I just noticed it now, when you pasted those videos, it only went to the panelists. So repaste those, maybe copy and paste it to whatever it says, panelists and attendees.
Okay. Sorry,
So
I'll just reply via email with all those videos that are resources.
Via email to all the students?
Yep.
Okay.
Or I'll send it to you and you can send out to everybody.
No, I don't have everybody's email, I don't think so. If you want to do it in this chat box, then people can grab it.
Yeah, I think I'll get Amanda just to send it out to everybody.
Okay. That'll work.
I don't know that I have it at my fingertips for all the other ones.
Okay. Okay, I mean, it'd be in the chat box if you just copy and paste it.
Okay. One second.
Okay. So not seeing anything else, the last thing we will do is just a little Mentimeter quiz. It's not graded. In fact, we don't even know who guessed what. Similar to the first one, it's 20 questions. If anybody would want to stick around, I can go over the results, but I think I'll give, say, almost 15 minutes. So you can take your time to do it. You can leave after that. But if you want, at about, let's see, it's 4:07 by the time I get the screen shared, it'll be, I'll give till, say, 4:20, and then I'll just take 10 minutes to go over it. So if anybody is interested, I don't feel bad if everybody leaves. It's been a long, long 3 days. So understand that. But thanks everybody for your attention. Hopefully this worked out okay as online. I know it's, it leaves some things to be desired, but again, you got to do your work from home and avoided travel, all those kind of things. So there are some benefits. So with that, good luck everybody this construction season. Everybody be safe, and we'll see you around again at some point. So I'm going to share this screen, which should be the Mentimeter. And if you can't see it, I'll paste in the Menti thing into the chat box. So when I start seeing some things coming in, I'll know that people got in. And again, it should go forward. If it doesn't, if it makes you stop sometime, that looks like somebody's in, so that's good. And in case everybody can't see it, I will type it in here. Okay, so back again. If anybody, again, wants to leave once you're done, certainly fine. We'll just briefly go over it. I'm not sure if others had an issue. Somebody had an issue that they couldn't get past a certain question. That had happened one other time when I was doing this Menti, so I'm not sure, somehow something gets set wrong on there. But let's just briefly go through here for those of you who do want to stick around. So what's the most common type of bridges? So the most common type are pre-stressed concrete beam bridges. So we showed a couple little diagrams of that. So that shows up in a couple of places. And then CIP piling is the most utilized piling. So the correct answer here is the middle one, which most of you got correct. Which MnDOT standard specification covers the majority of cast-in-place concrete bridge construction, placement, and curing? So we mentioned how 2401 just has an awful lot of information. So be familiar with that. Everything from your substructures to superstructures and so forth. So looks like somebody else is stuck at a question. So yeah, for some reason it's not letting us pass there. So again, concrete bridge construction, you're going to see an awful lot of things in 2401. So just be aware of that. Which of the following are required by spec 2404 for curing low slump concrete wearing course placements, and select all that apply. So apply AMS curing compound when concrete can be walked on. That's not true. A lot of times if you wait until concrete can be walked on, it's going to already start having shrinkage cracks in it. So AMS is good on the top of the surface, but not waiting as long as it takes to be able to walk on them. But the next one, apply AMS within 30 minutes. Yes, that is correct. So that's one that we'd want to do. Place wet burlap or curing blankets as soon as concrete can be walked on without damage for a minimum of 4 days. That's also true. So it kind of gets a two-component type of a cure. This one, add water every other day to the burlap. That might be sufficient, but it also may, during the interim time, it might be drying out. So this is not really correct. You need to keep it moist. And then this one, maintain burlap in a wet condition for entire curing period. So that is correct as well. And then this one, there is a lot of cement, but we need curing. And actually, it's one of the reasons for curing. So 3 of them are correct here. AMS within 30 minutes, place the wet burlap. as soon as it can be walked on and then maintain a wet condition. Prior to bridge deck placement, which of the following are required by specification? So we're placing a bridge deck. What do they need to do? Deck placement and curing plan, at least 14 days. Yes, contractor needs to do that. Schedule a pre-placement meeting the morning of the pour. No, we want to be in advance of that. So the specs say 2 to 4 days. So the morning of the pour, that's too tight. You know, if something needs to be changed, is there even time to get more people to do whatever? You do need to do a dry run for the bid well. So the bid well is a full depth deck, so that is needed. Top mat is tied 100%. Very good. Yes, we do need to do that as well. So that's you know, in the rebar spec. And then this one, the air temp is above 45 degrees. That's not necessarily true. Concrete, if there's cold weather provisions, there'll be additional things, but it doesn't necessarily have to be above 45. It's a good idea, but you could pour when it's in the lower 40s, so long as it's the temperature is rising. What's a typical curing period for a structural concrete deck? So that one is 7 days. So again, remember the tables we looked at, 2401-1 is the main curing table. And there's kind of 3 curing tables related to curing in 2401. So be familiar with them. But 7 days is a big one there. So these other ones are 72 and 96 are too low. And then these guys, the 14 and 28 are, you know, it's great to cure that long, but it's not required by the spec. For an HP 12x53 pile, what does the 12 designate? And so that is the dimension of the pile from flange to flange in inches. And so then the 53, the question we had the other day, that's the weight per foot. So that would be this if it's 53, but for the 12, what does the 12 indicate? It's that dimension from flange to flange in inches. Which of the following is true for bar A608? So our bar designations nowadays are no longer in metric. So that's in 1/8 of an inch. So it's 6/8 of an inch or 3/4 inches. And so this millimeter one of 6, that's not correct. You know, if this was a metric bar, that would be, I think, a 19. I think the number 6 is a 19. But that is incorrect. It's not epoxy coated. If it's epoxy, there would be an E at the end over here. And bar 608 inches long, that's not true. But we do know the bar is uncoated because there's no designation here. So an E would be epoxy coated and S would be stainless steel. Pre-stressing strands, typically used in fabrication of pre-stressed girder, has this ultimate tensile strength, so the 270. So we talked about that a couple of times. So again, it's high strength. So just remember that your strands that you have in pre-stressed girders and used in post-tensioning is high strength. So our typical rebar is 60 KSI, but the strands is 270 KSI. Which of the following curing methods is not allowed for bridge structural slabs? Select all that apply. So the only one that is allowed for a structural slab, remember the structural slab is the 7-inch slab, and then you're going to be putting a wearing course on top. So the only one that is allowed is this one, conventional wet curing within 30 minutes. So that would be incorrect for the way this question was worded. If you spray AMS on there, it would provide a bond breaker. So you don't want to spray a bond breaker. Berlin is no longer allowed. So Paul Pilarski spoke about that one. So that would be a correct answer for this question. It's not allowed. And conventional wet curing as soon as it can be walked on without marring, that's also not allowed. It has to be within 30 minutes. So The way the question was worded, which is not allowed, it'd be the last three of those. What's a typical cover from the top of a monolithic full depth deck to the top mat of rebar? And that is 3 inches. If we're on a structural slab, it would typically be 1 inch because you're putting 2 inches on top. So in either way, you're going to end up with 3 inches of clearance. So correct answer is 3 inches. What's the name of the abutment type with a single line of piles and no joint in the deck above? And very good, that's integral abutment. So the semi-integral, by the word, integral is included there, but that has 2 lines of pile. And then a parapet abutment would have a joint in it. And in a spread footing, you might, well, no, you wouldn't have an integral abutment with a spread footing. I think you'll always have a single line of pile. So integral is the terminology there. When reconstructing an expansion joint, which of the following are required? And again, select all that or reply. So we want to use equipment that avoids damaging the existing surrounding concrete. That is true. Remove concrete 4 feet each side of the joint. We probably didn't really go over that, but it's typically about 18 inches, 1'6". So you got the joint, you go 1'6" this way, you go 1'6" that way. So in total, it's about 3 feet, but it's definitely not 4 feet. This one, extend gland above the extrusion end in the barrier and cut it horizontal. That is true. So that's what we want. Make sure that that gland gets up there. So if it gets too short, water could pour out if it's pooling there. Use oil to ensure the gland slips in an extrusion? No. What's used is a lubricant adhesive. So it kind of acts as a lube and as an adhesive. And then you use an expansion joint system that's on the APL. That is true. There's a list for the single strip seal as well as for the modular joints. And then this one, yes, to prepare the existing concrete, you sandblast and you scrub bonding grout into it. Which of the following are true for driving CIP piles? Select all that apply. So test piles, 125% of factor design load? No. Test piles should be 115% of required nominal bearing resistance shown on the plan. So this one is true. So test piles get a little bit more just to make sure that we are getting to a good point. This one is also true, the WEEP analysis. So that's done prior to going out there. The contractor uses the WEEP analysis to qualify the hammer. And so that will show that that hammer will operate between 30 and 180 blows per foot as it gets down to the final capacity. Every pile should be redriven to check final capacity. No, we don't need to do that. Now, you may want to check a few piles, but you don't need to redrive every single one. So that's not true. And then each pile shall have a driving shoe at the bottom, which needs to be watertight and no more than 1/4 inch larger than the shell. This is true. So a CIP pile are those round tubes. They weld a little plate on the bottom, but you don't want them too big. If you made it, say, an inch bigger, it would then cause more soil to be displaced, and then part of the frictional component wouldn't be able to happen. The 2 methods defined in the specs and used for steel bridge fabrication assembly are, so it's line assembly and full assembly. And so as Nick was mentioning about that, the line assembly is like a single line. They don't need to put things together, but there's also then oversized holes for some of the diaphragm connections. So things will be able to go together. A full assembly is often used on the more complex bridges, the curved bridges, and so forth. And those get put together, side by side, drilled in place, and then also they'd have to be put together in the field in the same way. These other options, welded option assembly, that's not really a term we would use. And shoring tower assembly, it's again not a term we would use, and the spec doesn't use it. The spec calls and talks about shoring and shoring towers, but it's not a named method in the spec. Which of these constituents can be part of the cementitious portion of concrete and HPC bridge decks? Select all that apply. So Portland cement, that is true. Portland cement is the main constituent in most. Calcium chloride, no. That is an accelerant, but it's also very corrosive. So we don't want to be putting that in our concrete. Fly ash, yes, that is true. And oftentimes fly ash is a product that's used, as well as ground granulated slag. And then silica fume is lastly the one. So Roundup oyster shells, no. So there's of this this chart, those four main bars are the ones that can be utilized. Most common method of constructing bridge traffic barriers. The most common is slip form. There still is a lot that gets done using cast in place using forms, but slip form is by far the most used today. A precast doesn't really get used that often. Perhaps in some ABC situations there might be some of those. Okay, looks like this is where everybody got stuck. So what are the required processes prior to or during placement of low slump concrete overlays? So we'd want to remove all oils from a structural slab. So we don't want a place that would be a bond breaker. Make sure the slab is dry. No. Actually, when I started, that was a requirement, but we started figuring out that the drier you make the structural slab, the more cracking you get in your overlay. And so now it's this one, ensure the structural slab is surface saturated prior to placement. And then apply bonding grout 15 minutes before and make sure it dries. Well, we do want to apply bonding grout, but we want to make sure it maintains wet. And if it starts drying, you need to reapply it. So that would not be true. A deposited low slump within 15 minutes, yes, that is true. And what else do we get? Voting is closed. And not sure. Backfill between retaining walls typically in loose lifts of how many inches? It's typically loose of 8 inches to get 6 inches compacted. And when performing shotcrete repairs on pier caps, it's important to do which of the following? Follow sequences laid out in the bridge plans or specs, yes. So pay attention. If there's a lot of deterioration and they say you can only do the north face and then get that patched and then do the south, follow those sequences. This one, not necessarily. Let's start moves from the center and work toward the columns. That isn't right or wrong, but it's not going to be a typical process. Limit removals to 4 square feet, not necessarily. Usually we can do much more than that, but watch what it is, and then use methods that avoid damage to in-place reinforcement. Yes. So you don't want to be saw cutting through and damaging stuff that could be salvaged. Which of the following are true for bridge repainting projects? So just-in-time training is available from OES. That is true. Blasting typically removes loose rust and mill scale only. So the word only, no, it removes much more than that. Stripe coat is applied only prior to the prime coat. That is true. So you don't need to stripe coat the intermediate and the final coat. Blasting, yes, it's typically to near white blast, which is termed this SSPC-SP10. Bridges older than 1980 need to have testing for PCBs and lead, yes. So that is a requirement. MnDOT performs all of the quality control checks for environmental compliance to the specs such as temperature, humidity, and paint thickness. No, that's up to the contractor. So MnDOT, you're there as a QA, but you're not the QC. And then all blasting waste and residue is considered regulated waste. That is true as well. So a bunch of things there on bridge on painting is true. So sorry we didn't, for whatever reason, Mentimeter didn't let us get everything done. But that being the case, that is it. Does anybody else have any last comments? Hopefully it worked out well for you folks. Hopefully you learned some things. Again, utilize the resources in the bridge office. There's a wealth of knowledge there. So with that, that's all I have. Good luck again to everybody this summer in your projects. Stay safe and be in touch.